Hey everybody, Jimmy and Jeremy from Carcass, and what you're looking at is our 1972 road course Camaro, which started out as a pretty nice street car, but we had other plans and turned it into an absolute track monster.
And Jimmy and I have always wanted to build a car to this caliber, and I think we pulled it off quite nicely. So sit down, buckle up, because you're in for one hell of a ride.
You're watching PowerNation.
Hey everybody, welcome to Carcass. Now we've transitioned off of our Datsun and we're finally ready to get our hands on our new project. It's actually been something that we've wanted to touch for about 3 to 4 months now, and it should be a great start to what we have in mind.
So this is our 1972 Camaro Rally Sport with the famous split bumper on the front. And the goal with this car is just to be a full tilt race car. And we have built race cars here before, and pretty respectable at that, but this thing should be even a few levels above those.
And this isn't the first Camaro we've built. We have done one before. Yep. But for you guys that are purists out there, this isn't even as nice as a 20-foot car, or a 20-footer as they call it. We have had this up on the hoist. It's got good bones underneath it. We don't have to put a floor in it or do any major rust repair. But as far as the outside of the car goes, it does have its flaws. Somebody has run into something up here with the nose cone, so there's damage up there. The hood's got 2 really big buckles in it, either from somebody trying to close it a little too hard, or wind catching it and it opening up as it was driving down the road. Plus, underneath the vinyl top here in the back, there are a couple bubbles forming. That means there's some rust underneath there, but nothing too concerning for us as far as the way the project goes. But all in all, this is a great start to what we want to do with it.
And the plan for this is to go a completely aftermarket suspension, do a 9-inch in the back so it will remain a solid axle car, do the cage work, and it will be a little more extensive than what we've done in the past. And the doors will be completely gutted. There won't be any glass in the car. We'll do a plexiglass windshield. And we want to do a little bit of carbon fiber work. It's going to have big brakes, and we want to do brake ducting, things like that. So there's a lot more work to it than what we can even explain. But something that's really cool is that we have a 4-speed dog box that ran in an actual NASCAR, so it has seen the oval. And for the engine, Pat and Frankie have a great plan as to what's going to go into this thing, and the 4 of us have discussed in detail what that's going to be. So guys, for the viewers, can you explain what's going to go in it, why is it cool, and why does it fit our car?
Well, one thing, we're going to keep it small block because it's easier for you guys to fit things up to it. And I like the small block because it's going to help with your weight bias, it's going to help with handling, but that doesn't mean it's not going to make good power.
No, it's going to be a pretty unique small block. So it's a Motown LS, which is a hybrid block. It's actually a small block Chevy bottom end, but you can bolt LS induction on it. So that allows us to have a really solid bottom end with great windage control, things like that. It's easy for you guys to get parts for, and it's easy to find parts that bolt to it, but we can get the benefits of a good LS induction, something that'll make good power. So it'll be a high compression, real race engine. It'll make, you know, over 700 very, very easily, but it should be an amble that you guys can beat on around the road course or wherever you want to take it.
It's going to have a really wide power band because, I don't know, not sure what you have for gearing, but for this type of operation, you're going to have a wide power band, so no matter when you stab the throttle, it'll be responsive.
Yep, and especially for a couple amateur drivers like ourselves, that's really going to help out. And so what about, like you guys say, it's a real race engine, of course, being around you guys, we kind of understand what that means now, but what does that mean to someone who doesn't know about the racing world?
Well, see, these things have better durability parts in them, and you need the durability because of what it's going to see for RPM, for abuse. So it's going to have better valve training, it's going to have, you know, high quality crank, high quality rods, high quality pistons. This particular engine, it's kind of like a street engine on steroids, but a true race engine does. It has compression. These take a little bit more maintenance. They take a little bit more babysitting to make sure they're always running good. There's nothing wrong with that, but that's what differs a street engine from a race engine. Race engines are higher output, and they take a little bit more care to keep them running right.
Everything we build is application specific, like we always say. So like a street engine spends 95% of its time idling around or low RPM cruising, and with a race engine, it's spending 95% of its time at its maximum output or somewhere in there, so the parts are stressed a lot more. Even though the amount of time they're being stressed is a little bit lower, they are being stressed more, so the parts really have to be good enough to hold up to that, and there is some extra maintenance involved, but that's just kind of what goes with building a race car.
So like the reality behind this car is it's going to be a real race car. It's not going to see any time on the road. So as far as us really kind of beating on this thing, it's going to take a beating, so we need something that's going to withstand how we drive, I guess.
And we'll have you guys out at the track to maintain this for us, because we don't want to be responsible for such a cool and expensive engine.
We wouldn't have it any other way. Part of doing the engine is, in a real race operation, is the engine builders go with the car, and they're the ones that are responsible for how well it runs.
Yep.
You know, the old the adage is, you know, the chassis builder gets you to the finish line. The engine builder determines when.
Oh, I like that.
Right.
Yeah.
Well, it sounds like we have a plan, right?
Yep.
I think from here on out, we know what we have to do. You guys know what you have to do. I think it's time for us to grab some tools. Let's get this car apart, and we'll start on our end. You guys just let us know when we can come down and maybe hear our engine run.
You'll hear it on the dyno for sure.
Yeah, or we'll come running down when we
We're gonna rattle the building.
Yeah,
Cool.
probably.
Let's,
Awesome. Let's
get
get
some
it.
tools and we'll
Cool.
get at it.
Thanks, guys.
The teardown begins. We start gutting our 72 Camaro to start with a blank canvas, making way for all of our new racing components.
All right, so now that you guys know a little bit about what we plan on doing with the Camaro, let me give you a little bit of history on the car itself. This is what is considered to be a second-gen Camaro. They ran this from about 1970 to 80 or 81. And ours is a little more unique in the fact that it is considered a split bumper Camaro, and that's exactly what it sounds like. In the front, you only have two small short sections of bumper on each side of the car, and that's split in half by the grille or the kind of the nose cone of the car. So they switched this up in 74, and they went with a full aluminum bumper up front, and then later on, a couple years, they decided to go to a urethane bumper or the plastic bumper just for safety regulations and stuff like that. So our car is a little unique in the fact that it is a split bumper Camaro. And this is also unique in the fact that this car doesn't have a full frame underneath it or a full chassis. It's what's considered to be a unibody car. And a unibody pretty much means that is when they built the car, including the floor pan, it's a bunch of pieces of metal that are bent specifically, and it's all welded together, making kind of a frame section that's part of the entire car. Now on the other side of that, it does have a subframe, which is like the front frame section that bolts into the unibody. The subframe houses all of the front suspension and the steering, plus it gives the engine and transmission a spot to mount to, including the cooling and like the core support and stuff. So when we go to take this car apart, it's actually going to be quite simple. We're going to take the front clip off the car, and the front clip consists of like the hood, the two fenders, the nose cone, and the core support, radiator, and stuff like that. And then from there, when we go to take the engine and transmission out, we're just going to unbolt the subframe, which consists of about 6 bolts. As we take those 6 bolts out, we're going to pull the subframe, the suspension, the engine, and the transmission clean out from underneath the car, and it'll just give us a really good platform to start building out the roll cage and whatnot. Now our car does have a 350 in it, or at least that's what the air cleaner says on the top. It's also a 3-speed automatic car, and the odometer shows 46,000-ish miles. Now, we're not sure if that's really 46,000 or 146,000, because back then, GM only ran 5 digits in their odometer, which means it only read up to 99,999 miles, and then it restarted over, so it started counting back from 0. So this car could either have 46 or 146,000 miles on it. And really just with the condition of the car, we're probably just assuming it's gonna have 146,000 miles on it just because it's pretty beat up for what it is. Now our car is a little higher option car. It does have air conditioning, it's got power steering and power brakes, plus it's got the vinyl top and the spoiler on the back, and it also is holding the Rally Sport badges on the side. Now with this being what would be considered to be a higher option car, don't get us wrong, it's not that nice of a car, but it is a perfect platform for us to start building our race car. So we got nothing else connected here.
Yeah, we're good.
Look at that jack spinning. It's gonna fall off, so just be careful.
Yeah.
Let it fall. Oh, it's sitting on the exhaust. Or it's actually sitting on the part of the subframe. Hey, look at that, that works.
Nice.
Well, here's one thing we did notice once we got the fender off. The car has been hit over here on this side. There's an old school repair here. It's really nothing we're too concerned about, and just one more reason why this is the perfect candidate for us to build a race car. Now, the structural integrity out here, we're really not too worried about, solely for the fact is we are going to have a roll cage in the car, so all of the strength is now going to be in that roll cage. So from here, we're going to transition inside, start getting rid of the interior, and make way for all of that to work. Stay tuned. To make sure we have plenty of traction on the track, we need wider rubber. We start cutting on the body of our Chevy, making room for much larger wheels and tires. Hey guys, welcome back. We started gutting the inside of our Camaro, including the full interior, dash, and we also removed the rear suspension. This will give us a clean slate to start with. Now that we got everything out of our way, our next task is to start removing the stock wheel tubs. With this car becoming a real race car, we have to make way for a wider set of wheels and tires. Using a template, we marked out our cut lines, suited up, and got to work. A job like this is a whole lot simpler when you don't have to worry about any interior pieces. This process can be done without removing the full interior, but it sure does make it a lot easier and a lot safer. Following our template, I'm cutting on the inside of our lines just to be conservative. I'll slowly start grinding away a little more material as we start test fitting our pieces. All right, so now that we have this giant hole cut in the back of the car, we're gonna be mocking up our wheel tubs. Now these are made by Detroit Speed and we picked them up at Summit Racing, and the idea here is to gain a couple extra inches on the inside of the car to run a bigger set of wheels and tires. Now a bigger set of wheels and tires means you have more traction, and traction can win you races. We're gonna be running a 315 square around this car, but you could possibly run up to a 335. Now, with this kit, they also send you some flat pieces of steel. Now, they send them to you flat for a couple of reasons. One, they're just a little easier to ship. And two, the variations in your cut lines between person to person can be different and change. So you have to bend these into shape to match the contour of your cut line. The reason why you're doing that is when you go to install your wheel tub, you're gonna have to have some kind of a lip to weld this wheel tub to. So the idea here is to take these pieces of steel, you're gonna have to set them kind of into place, and you have to make a couple marks with a Sharpie, and you're gonna have to bend them to kind of match the contour to build this lip. Now, you can do that a couple different ways. You can take this over to a bench or your vise, and you can kind of start bending them into shape. You can just use a solid muscle with your hands. They're not that heavy, they're not that hard to push, but it could be a little bit of work. Or if you have a hammer and a block of wood, you can do that too. So what we're gonna end up doing here, setting them up here into place, we're gonna grab a Sharpie, make a couple lines, we'll go over to the bench vise, that's the easiest one, and we're just gonna bend these things into shape. And somewhere in this general area. On some of these bends, you need to sneak up on the radius, so little bends spaced apart evenly will give you a nice sweeping curve. All right, we'll set this in here. It's close-ish. We've got one bend done, but I gotta do a couple more bends to get it to fit right. So mark it here a little bit, we'll go bend it again. Other bends call for a little more persuasion. Okay, well that fits pretty good. Now one thing to note is you're gonna wanna leave this little flange up a little bit from the floor of the car. The idea here is to mark a line on this big flange, take it off, cut it so it matches the floor contour, and then from there you can weld it in. It'll give you a nice corner joint to weld and give you a good finished look. Now, we're not going to be installing these. We're actually not even going to install the inner wheel tubs, and we're going to do that for a couple reasons. One, we do have a roll cage that needs to get in here, and this is a good access point. Plus, we've got a fuel system to tackle. And the third thing is we're going to be doing some suspension work down here, and it's just beneficial to us to keep this all open so we can tackle that a little bit later. So what I'm going to do is just kind of finish the back. I'll create this flange, put a couple bends in it, and we'll go ahead, tackle that fuel cell.
Before we start building out the roll cage, we need to make sure we have room for our fuel cell. We mock up and cut out the best place to accommodate the new tank.
The next thing we're going to work on is getting the fuel cell in the back of our Camaro. We just want to get as many components back there as we can right now. That way when we go to build the cage, we kind of know what we have to work around, and that way we don't have to go back later and change some stuff. So we've got this awesome setup from Radium Engineering. They sent us a fuel cell with all the good bits on the inside. They also sent us this cage to actually install it in there, and this saves us quite a bit of fabrication work. We'll talk about this later when we actually go to plumb the car, but for right now, we're just going to try to get this in the back of the Camaro. Now, there are a few things to consider when you're deciding where you want to put your fuel cell. In most cases, you'll probably end up somewhere in the back of the car, just like in our Camaro. And in our case, we're going to cut out a big rectangular hole and sink this thing down as far as it'll go. But you still have to be mindful of how big the fuel cell actually is. If ours was a little too wide, it could potentially interfere with the rear axle or other suspension components as they go through their motion. Something that's really cool in high-level race cars that you could also do is put the fuel cell in the passenger compartment. And what this will do is concentrate more weight near the center of the car, making it more responsive to the driver's inputs. A good example of this is something like a figure skater. When they have their arms in, they tend to spin really fast, and when their arms are extended, they spin much slower. So in our case, we feel like going in the back of the car is going to be just fine. So what I'm going to do here is actually just flip this thing over, mark out the rectangle, and we'll cut it out.
We don't have to be too precise with the cut here because the fuel cell cage has a nice big flange on it. The reason why we are sinking the cage down into the floor is because it'll help keep the center of gravity lower overall. I'll clean up the edges with a grinder before grinding the paint off for future welding.
Okay, so holes cut out. This thing should fit no problem. And it does, however, right now it's not sitting flush with the floor. And that's because on the bottom here, there's these tabs, 2 on each side. So I'm just gonna go ahead and set this back in, mark out where these little slots need to be cut them out, and then this thing will sit nice and flat with the floor. Got the cage in here now, and it sits nice and flush with the floor. And I don't need to put the fuel cell in, but these look really cool, so I just wanted to take a peek at it. But this will give us a pretty good idea of any obstructions we might have when we're fabricating the roll cage and the rear firewall. So we're not going to tack anything in right now, just because we'll probably be taking these out and putting them back in several times. But when we go to put it in the final time, I'll just do a stitch weld around the outside, and that'll be a good installation.
Wow, that looks really good. How did it go?
All good. This will be a nice location for the fuel cell, and we're starting off in a good direction with some high quality parts.
Right, I've got the passenger side pretty much buttoned up for the wheel tub area. I just have to bend and add these two pieces to the driver's side, and we'll be ready for the roll cage.
Yep, and with everything in it, we'll have a really good idea of where the rear of the cage is going to land. And we've done a lot of cages before, but this one's going to be a little different because there's a few unconventional fabrication techniques we're going to use to build it. So.
Yeah, and some cut lines that are going to be a little crazy. So
Yeah.
I'll get these in and we'll keep moving on.
Today on Carcass, we work on strengthening our 72 Camaro's body with a fabricated roll cage that will also keep us safe.
Plus, the 51-year-old suspension can't handle all the twists and turns on the racetrack. So we'll strip down the old subframe to make way for modifications to accept the new drivetrain and the new suspension components.
What's up, everybody? Welcome to Carcass. Jeremy and I are back on our 1972 Camaro, and as you can see, there's not a single part on the inside or the outside. The next thing we're trying to tackle is fabricating the roll cage, so having nothing on the interior is a great place to start.
And there's three major parts to this build. We need horsepower, we need traction, and the biggest thing I think of all is our safety. So Jimmy's got a really good idea on how he's going to lay the cage out. We have done a couple of things for him to work around. We did put in a set of mini tubs back here. Plus, Jimmy went ahead and installed the fuel cell in the back as well, so he's going to have to work around that, and I'm sure you've got a pretty good idea how to do this. It's all in your head.
Yep, and the first thing we're going to tackle here is just making some base plates, and we also have to clean the floor just to make sure we can get a clean weld, so that's where we're going to start.
So the spots that we're going to be cleaning up for the base plates is this big flat area right here in the back on both sides. Plus we've got two little areas to do up front. We're going to be using this crud buster, and that should whip right through the paint. We're using the crud buster because it doesn't remove any of the actual material or metal from the floor. All this is doing is removing the paint and the seam sealer. Then we'll switch over to the bristle disc to do a little bit of polishing.
Now that Jeremy has these areas cleaned up, I wanted to talk about why we chose these areas to put our base plates on and ultimately land the roll cage. So back here we have a nice flat area. It'll obviously be behind the driver's seat, but also under the car is kind of where the rear frame rail section starts. So this is just a nice flat, strong area for the main hoop. Up front is a little bit different just because we have less room up here. Our feet are going to be up here, the pedal box is in the way. So we would just want to make sure that we can keep our legs as far away from the roll cage as we can. So what we're going to do is make a plate to cover this body plug hole, and then also have a plate up on this inner rocker section. And this whole rocker section here is one of the strongest parts of the car. So we're going to notch the tube to land on the inside part of that and also touch the floor. So I've got these templates made up. I have to get to the plasma table and cut these out, and then we'll tack them in. After cutting out pieces on the plasma table, I always like to use a grinder to get rid of the hardened edge, as this makes it a little bit easier to weld later on. And I also like using a DA sander to clean up the faces, just to get off any surface rust and mill scale. Some of these base plates I'll put some bends in just to make sure we get the fit as tight as possible to the floor. All right, so that's all 4 base plates tacked in, and something that's interesting about this car is just how different the base plates are from side to side. Some of the bends I had to put in just a little bit different location, and that's not uncommon, but the thing you want to make sure that you get right is the gap between the plate and the floor, because if you have to weld across a gap, it's just going to make your life a whole lot harder. But now that I've got these in, I can start working on the main hoop. Coming up, we start the process of cut, bend, notch, and weld for our road race roll cage. It's finally time for us to start on the roll cage for our Camaro, and we are using 1 3/4 OD by 120 wall tube. And mild steel DOM is pretty much the standard for roll cages. And in our case, when you use a 1 3/4 OD tube, you usually only need an 095 wall, but we're going a little bit heavy duty with the 120. And we're gonna start on the main hoop. It's gonna have 5 bends, and the tube has to be 119 inches long. To bend our cage, we're using the Rogue Fabrication M625. With a wide selection of dies, this bender can handle anything we'll throw at it. Some details I really like are that this bender can bend past 90 degrees in just 1 stroke of the hydraulic cylinder. And another is that the clamp block on the tube can come out of the machine, which makes it easy to finely tune the bends on this main hoop so we can achieve a great fit. Pretty good. Having the cage fit tight to the body has multiple benefits for driver safety and performance, and Rogue Fabrication's bender will help us achieve that. This is the best bender that I've used to build a roll cage. It's very easy to use, and I didn't have to give a second thought to landing these 5 bends in the same plane. Guy up and in here.
You gotta tell me kind of where you want it.
There. So I got the main hoop in now, and we tweaked on this thing a little bit, just kind of crept up on the bends to make sure this thing fits like it should. We've got about an 1/8 inch gap on each side of the car, and it actually touches the roof. So we'll be able to weld to the car in 3 places, which is really good. This is just a great base for the start of the cage. So we'll start working on the diagonal brace, harness bar, and the 2 down bars. Okay, so for the diagonal bar, I put a piece of tape here, and obviously I can just measure this with a tape measure. To get the angle of our notch, I zeroed the angle cube against the main hoop, and then I'm just going to take this and kind of hold it roughly against the tape. It's somewhere in the 43 to 44 degree range, and I can do it down here at the bottom as well. This reads about 35, 36. Got this diagonal brace cut and notched, and it fits pretty good. So it's pretty much the same thing for the rest of the tubes on the back half. But just to make sure nothing moves, I'm gonna go ahead and get the main hoop tacked. And you'll notice I've got all these areas where I think I'm gonna have a tube come into contact. I've got it prepped. I just use Scotch-Brite to scrub the mill scale off. So grab the welder and get this thing tacked up. When you're building cages or other tube structures, you want to take your time to get the joints fitting as tightly as possible. I can tack in a lot of these tubes without a filler rod because of the fit up, and that's also helpful just in case you don't have someone to hold the tubes for you at that time. To notch our tubes, we're using Rogue Fab's Versa Notcher. It's quick and precise to adjust using cam locks. Our roll cage is pretty straightforward, but for more complex tube structures, you can use this notcher to clamp on bends or do offset notches. I made some base plates to tie in the roll cage to 2 other points on the rear part of the body just to increase the rigidity of the car itself, which should help us with performance.
All right, next step, seat placement for the harness bar.
Yes.
Okay.
Yep.
I'll crawl in here.
Got to figure out where our shoulders are going to be. A really important part of building the roll cage is getting the location of the harness bar correct. That's where the shoulder belts of your 5 or 6 point harness are going to attach to the cage. And in most instruction booklets that you get with your harness, it'll specify that you need it at 0 degrees or up to 20 degrees below the shoulder line. So we're going to use this big square to simulate a belt. And then I'm just basically going to measure along the main hoop to see where our tube needs to land. All right, that's about 23.5 off of the base plate. Well, that wraps up the back half of the cage. So at this point, I just have to cut the tacks where it mounts to the base plates, carefully remove this thing, weld it all up, and then I can move on to the front.
Our subframe has seen better days. We start the tear down to make room for our new racing suspension. So now that Jimmy's been working on the roll cage, figured it was a good idea to start here on the subframe and the front suspension for our Camaro. Now we've talked about subframes before and the fact that they're a little unique, but manufacturers had different reasons for running these things. One of them was the fact that it was a big weight savings. So you have to imagine a full frame underneath the car versus only half of the frame underneath the car. You have half the weight. The other is for pure efficiency when building the car. So if you imagine a full frame car coming down the assembly line, you're going to have another group of guys come in at some point to build out the suspension, to build out the steering, set the engine and transmission in it, versus when you have a subframe, you could have the car being worked on one side of the assembly line, and the complete opposite side, you could have other guys assembling this full subframe setup with the engine, transmission, steering, brakes, all that stuff into it. And when it comes to meet on the assembly line, it's literally only 4 bolts that bolt it together, and the car keeps moving along. And we're only interested in using just the 2 frame rails of our subframe, so everything's got to come off of here. So we're going to get rid of all this junk because we're going to get this thing all cleaned up, and then we're going to start building out the suspension for our Camaro. There's a couple things we need to remove before we get to the suspension, like the AC compressor and the headers. I'm choosing to leave the engine in at this point because I want to keep the suspension under load. This will just help with disassembly a little bit later. At least everything's coming apart nicely. One thing to note, when taking your suspension apart, be mindful of the pressure or the energy stored in the coil spring. It can be deadly. Make sure you do this carefully and pay close attention to the forces on the suspension pieces. The disassembly process is the exact same on the other side. And with the suspension completely out of the way, we'll move on to removing the engine and the transmission. At this point, it's only held in with a couple of bolts. Get this thing up high enough to clear every cross member, steering, all that stuff, but it works really good with this engine sling. We got 4 solid points of mounting into the engine, and it keeps the engine sitting pretty level too. All right, that should do it. Let's see if we can get this thing out of here. That's a beauty, Clark. Up next, we make some small modifications to our subframe, then raise the roof on our Camaro. Okay, now that we have the front subframe pretty much stripped down to its bare bones, we're gonna get ready to get this thing cleaned up. Now, there are a couple of things that we're gonna do before we get to the actual cleanup. We're gonna be running UMI's front suspension on this thing, and it has a set of coilovers. To run their coilovers, we have to come into this upper control arm mount bracket here and make a couple specific cuts to get this piece out of the way. Now, we're not gonna be installing the suspension right now, but what we are gonna do is get this out of the way. That way it just makes it a whole lot easier to get it all cleaned up, get this down to bare metal, because we are gonna have to do a couple mods a little bit later. It's pretty simple to get it out of the way. Got the old cutoff wheel here, so we'll make these 3 cuts on both sides. We'll keep moving on.
The roll cage is almost done, and I have a few joints up top that I need to weld around, and I do have a roof bar made that I need to put in as well. And in the past, we've basically used 2 methods to get to the top of the roll cage. The first one is using a hole saw to cut holes in the floor to drop the cage down, or we build the cage on plinth boxes, which also allows us to drop it down. Basically what we're trying to achieve is just to give some room between the cage and the roof so we can get a TIG torch up there. But the third method, which we're going to show you guys, is actually taking the roof away from the cage. So we're just going to cut the A pillars and the B pillars, lift the roof off, do what we need to do, and then weld the roof back on. Oh, Camaro convertible.
That's crazy. That's how you do it, though.
With the roof off of the car, I can finish welding the joints up top as well as put in the roof diagonal bar. For the cage itself, I prefer TIG welding just because it leaves a little bit nicer of a finish, and that's what I'm comfortable with, although it does take a bit longer. You can also MIG weld this if you want to do it a little bit faster, but just choose whatever you're comfortable with. That does it for the welding on the cage, at least the tubes. There's quite a few taco gussets and things that I want to add in different areas. But the nice thing with the roof off now is we have tons of access to every part of the car. We want to make some panels and other things on the inside as well. So for now, I'm just going to clean up my mess on the inside.
Today on Carcass, it's all about handling. We'll finish cleaning up our subframe and give it some added strength before installing our new race suspension.
Then, we bolster up the rear for better traction and to handle more horsepower with new leaf springs and a performance rear axle.
Hey guys, what's up and welcome to Carcass. Now, believe it or not, the car you see before you is a 1972 Chevrolet Camaro, and I know it doesn't look like much of a car right now, but that's just because we're deep into the fabrication process. Now, Jimmy has gone ahead and whipped out an amazing roll cage, so the car should be a lot stiffer, plus a lot stronger. Also, we went ahead and cut the wheel tubs out. We added a wider set of wheel tubs or mini tubs, that way we can run a wider set of tires. Now, probably the biggest thing you're noticing right now is the fact that the car does not have a roof on it, and we did that for one specific reason. As you come to weld up the roll cage, it's really hard to get your TIG torch up here on the top, especially when the roof skin is so close. So the easiest solution to that was to just grab a cutoff wheel and whack the roof off and get it out of the way. Now, don't be too worried. We will be putting the roof back on this car. We just have a lot of fabrication to do on the inside. Makes it a whole lot easier when we don't have this roof skin in our way. Now, transitioning off of the body of the car, we are going to start working on the front of the car, or the subframe. Now, I already went ahead and stripped out all of the suspension. We've got the steering out of the way and the engine and transmission out of the way. Now, this thing had over 50 years of grease and grime on it, so we loaded it up and headed out to a local sandblasting shop. Now, we went to the guys over at Blast from the Past in Lebanon, Tennessee, and they got to work right away. They used a crushed glass or a glass media to clean up our subframe. It's a little more aggressive, but again, with all of the grease and grime that was on our subframe, it worked very quickly. Now they managed to get into every nook and cranny, and that's what we needed because we're gonna be doing some modifications to this subframe for our suspension. Now the suspension system that we are running is from the guys over at UMI, and they send you this little template or this little cutout because we do have to do some modifications up here to the coil spring pocket to run their coilovers. So it's simple as just kind of setting this into place. We got a marker, we'll trace it out, we'll get to cutting, and we'll start welding.
Now this could be a little tricky because it's just paper, but they also say in the instructions to make this more of a roughed cut. Then you can always come back and trim it to fit perfectly.
The easiest way for us to make this cut is to use our plasma cutter. If you don't have a plasma cutter, that's fine. Just grab a tool that will get the job done, like a regular torch or a cutoff wheel. And after a little bit of fine tuning and a test fit, we're ready to tack our collar into place. Okay, so the collar's in the subframe now. The last piece that we have to install for this part of the kit is this upper coilover mount. It kind of goes into the original mounts here and bolts in, but you do have to make a small little cut on this upper part of the mount, so we'll mark that out. And then we'll trim this part out to fit, get this all in here, and then we'll weld everything up. This is super quick work and such a small cut. So instead of using a plasma cutter, we chose to use a cutoff wheel. All right, that's gonna take care of this side. Everything's just tacked into place for now until we get the full suspension in the car. I've got a couple more tacks to do here just to hold it into place, and then we'll tackle the other side. Coming up, we clean up the old factory welds on our subframe, then add some modifications to make it stronger for the track. All right, guys, moving on with the subframe for the Camaro. Per the UMI instructions, it says it's a really good idea to come in here and kind of groove out, V out, or just get rid of the factory welds for this upper control arm mount, and then come back and then re-weld it all back together. Now, we started doing this on the ground, and we had a good idea to bring in this table and kind of use it as a chassis table. Now, we're doing that for one good reason. As we start driving all the heat into these joints from welding, there is a chance that this subframe could twist or turn a little bit, so we're actually going to weld the subframe directly to the table to try to stop that from happening.
And while our subframe is sandblasted, there still is some dirt and grime in the edges that we need to clean out, just so we can get some better penetration with our weld. So that's what we're going to start on first.
Using multiple tools, we're going to clean up the areas we need to weld to make sure they are as clean as possible. We'll weld on a couple stands and then flip the subframe over. Look at all that stuff fall out of there. Right? Here. Then we'll weld that to the table. We'll do the exact same process on the bottom side of the subframe. We just want to make sure that we get all the grease and grime away from the welding areas so our welds can be as strong as possible. Once we're satisfied, we'll fire up the welder and lay down some beads. We'll skip around the subframe, making sure we don't put too much heat into any particular area. Stands back on the bottom, flip it over one more time, and we're good to go.
Sounds like a tedious process.
Right? The forces that our subframe will see on our Camaro are going to be quite a bit stronger than the forces you would see on a normal car on the street. That's why we're taking the extra time to strengthen our subframe with some stronger welds.
All right, well, we got our subframe all welded up. Jeremy did a really good job on these welds. He did do a little bit extra up front here to strengthen it for our steering forces that we're gonna see, so it should be nice and strong.
One thing to note, if you guys are doing something like this at home, there are oils that are driven down deep inside of these areas where we ground out to weld, so you may have to do a hot pass over the top of that to kind of draw those oils out. Then you'll have to re-clean it, and then go ahead and lay your final weld in there. Now, we're pretty much buttoned up doing all the modifications on the subframe, so we're gonna do a little more cleaning on this, get the slag off, and then we'll move on to the suspension.
Let's get to it.
With our subframe ready to handle the forces from the track, we can start bolting on our new performance suspension.
All right, guys, we have buttoned up the modifications we're going to be doing to the front subframe on the Camaro, and that's all been in preparation for this. This is the suspension we're going to be running under our Camaro, and we got this from UMI Performance. Now, not only do these guys obviously build everything right at their facility, they also have their own racetrack so they can test and tune and put these things through the ringer, so we know it's going to work perfectly underneath our Camaro. Their front kit comes with the upper and lower control arms. We have all the hardware to install it, and we opted to go with a bigger splined sway bar in the front just because of the increased loads we're going to be seeing. Now, this is just their front kit. We are going to be running their rear kit as well, and the only thing you don't see on this table is a set of coilovers, and that's because we do have to take a measurement to get the right length on the coilovers. We'll show you guys how to do that a little bit later. To get this started, I got to grab a couple of these sleeves, and we're going to press them in to these lower control arms. Some of these are easier than the others. This one kind of went right in on its own. Before we install these into the subframe, we'll put on the lower coilover brackets supplied in the kit. All right, these might be a little snug just because of the variations in the chassis, so we'll get it up here. You can kind of give it a little tappy tap into place here.
Hit it with my purse.
Yeah, go ahead. There you go. Yep. Keep going. Keep. Little bit. A little more than that. Oh, just a little now. One more. All right, a little more, and we'll see if it goes in. Ooh, I like that one. This is gonna come up. Push in a little, maybe.
close.
There we go.
Slide that one in here. Let's see if we can get this one in too. Okay. Right there, actually.
Sweet.
Can you get that in there? One.
Oh, it needs to go up a little bit.
Let's move that up and down a little bit.
There we go. Okay, so we have the upper and lower control arms on now. The next step is to find a spot to put this little bump stop that comes into the kit. The guys at UMI in their instructions say to bring up the lower control arm and kind of use this as a template, if you will. Figure out where it needs to land. And then we'll come in, mark it, drill the hole, it goes right through the chassis, and then we'll tighten everything down. Somewhere in there. All right, up next on the install list are the front spindles. Now these are CPP spindles and we got them from Summit Racing. You guys are gonna notice one very unique thing about this, and the fact that they run an outer wheel hub from a C5, C6, or C7 Corvette. They actually run the braking system from that as well. What that does is it just kind of opens up the door and allows us to run more of a performance braking setup on our Camaro, which we're definitely gonna need. Now the reason why they do that, or the reason why you use an outer hub like that, is it gets rid of the pin flex inside of a stock spindle. The pin flex, what that can do is that can create knockback. And what knockback is the fact when you guys go around a corner really hard, that pin can actually flex a little bit and it will push the piston in the caliper on your brakes. That's gonna give you very inconsistent braking, especially when you're out on a racetrack. These install right into our UMI upper and lower control arms. They actually install in any stock upper and lower control arms. So we'll go ahead and get these installed here. We're gonna keep moving forward. All right, normally now we would be installing the coilovers, but we don't have the measurements for those quite yet.
So what we're going to do for now is install these All-Star Performance setup rods that we got from Summit Racing. And what these are going to do is they're going to simulate a coilover when installed. So once we install these, we'll set everything to ride height, take our measurements, send them to UMI Performance so they can send us our correct coilover for our Camaro.
All right, well that takes care of the mock-up on the suspension for our subframe. Now the one thing that we can't do yet is install the big sway bar that runs across here, and that's solely because these big bars are in the way, but we'll take care of that once this thing's on the ground and it becomes a roller.
So for now, we're going to move on to the rear and get that suspension set up.
I'm gonna grab some tools and just tighten this stuff down.
Well, I'm going to go help Jimmy with the rear end.
Our front suspension is done. Now we can make improvements to the rear, starting with the axle. Jeremy has a great head start on the front subframe of our Camaro, and now it's time to move on to the rear. And just like the front, UMI Performance sent a bunch of great parts for us to run on our car. Up front here we have the stock leaf spring from our Camaro, and these two are from UMI. They have a little bit of different arc, so it'll give us about 2 to 2.5 inches of drop, and they come with Delrin bushings to take the slop out of the system. The other big component to this is the front leaf spring mount. It has the Herb Adams mod built in, which basically just changes the front mounting location, and the bracket also houses the front end of the traction bar. The other end mounts to the U-bolt plate.
And what the traction bar does is it basically reduces wheel hop and it prevents axle wrap, so we get more traction to the tires. And that's really important for us because we're going to be sending 700 to 800 horsepower through racing slicks, and we need all the grip we can get, and UMI stuff is going to take care of that just fine. They also sent us their rear sway bar kit, which has 3 adjustments so we can really dial in the balance of our car. And on our Camaro in particular, because it is an early 2nd gen, we would have to drill a couple holes in the frame rails to install the kit, but otherwise all the late 2nd gens have the holes already in the frame rails, so you could just bolt the whole thing right in. And that's the great thing about this kit is if you are running a 10-bolt axle, which came stock in this car, this entire kit just bolts in without an issue. However, we are running a 9-inch and we've modified the chassis a little bit, so we'll have to make a few minor tweaks, but nothing major. So for right now, I'm gonna get these springs in and then we'll move on to the axle.
Can you swing that in that way just a little bit? There we go.
As I mentioned earlier, we're going with the Ford 9-inch axle, and we got ours from Quick Performance in a full floating configuration, which is a huge upgrade over the stock 10-bolt in both strength and safety. In a full floating axle, the axle shafts only handle the loads through the drivetrain, and then there's a separate hub and bearings to take the load, which is the weight of the car. In a flanged axle, it does both. And so in our car, we wanted to keep it as safe as possible, and it's geared for almost 170 miles an hour. So in the event that an axle shaft breaks, the wheel will stay on the car, whereas again, in a flanged axle application, your wheel's coming off, and then Jeremy and I would be in for one heck of a ride. So Quick Performance, they sent us everything we need to get this thing under the car. They sent us the 9-inch center section with 325 gears and a 35 spline locker, the axle shafts, which are absolutely massive, the hubs in their respective bearings, drive flanges, and they welded on the spring perches at the stock Camaro width, so we can just throw this thing under the car without much issue. But I did say we had to make a couple tweaks to get all this to work with UMI suspension kit. That's because when we mini tubbed the car, we cut out the stock shock mount, so we're gonna have to remake that and remake it on the axle. UMI's U-bolt plate has a specific pattern for the 10-bolt with the shock mount integrated. So what we did to solve this problem was make a more traditional U-bolt plate, and then we just copied UMI's traction bar geometry. So all of this stuff from Quick Performance and UMI suspension kit is gonna work awesome. All I have to do now is just get this axle housing under the car. All right, Michael, let's get this in. All right. We'll set the axle on top of the springs and secure it with these Detroit Speed U-bolts that we got from Summit Racing.
All right, slow down. Should be good here.
All good?
We're all in.
All right, so that'll do it for the rear end axle housing, getting this thing mocked up. Next time we'll get the front subframe in and make this thing a roller.
Today on Carcass, we have to make room for our drivetrain. We have a few modifications to help make our engine and transmission bolt into the subframe.
Then it's time to cut out the firewall and trans tunnel to make room for all that power. Plus, we'll show you how to measure for a set of custom wheels.
Hey everybody, welcome to Carcass. We have a big day planned in the shop today. We want to make our road course Camaro a roller, and that entails us putting the subframe underneath the car, but not before we set the engine and transmission in between the frame rails. But this isn't just a simple bolt-in deal.
And that's because we're going to set the engine and transmission back to help improve weight distribution of our car. And we're going to set it back somewhere in the ballpark of 6 to 8 inches, and we're going to motor plate it up front to the subframe, and then we'll have to figure out some kind of transmission mount.
That's not all the fabrication we're going to be doing. By moving the engine and transmission back, we're going to have to cut a big hole in the firewall. But really, the first step for us to get moving forward here is to just get the sling on this thing. We'll set it in between the frame rails. That's probably pretty good.
All right. Now we got to go back. Backwards.
Backwards. Like way backwards. There. So like Jimmy had said, we are going to be running a motor plate in the front, and really all this is a giant piece of aluminum specifically cut to act as like a motor mount. In the back, we are going to be using the transmission mount. We just have to figure out where that lands. So for now, we're going to get this in between the frame rails, and then we have to figure out how we're going to mount this motor plate to the subframe. Keep going. All right, it's kind of resting there now.
About 10 to the bottom of the block. With that measurement, we can start making our cuts to the motor plate.
Okay, one reason why Jimmy took that measurement is because we need to pay attention to the bottom face of the engine block, or where the oil pan meets, to the top or the leading edge of the cross member. Now we're going to be running a dry sump oiling system, and we know the pan measures about 7 inches up here in the front, which is quite a bit different than a standard small block oil pan. So we want to make sure we have the clearance there. It's not too critical for us. We did move the engine back quite a ways. It's not really going to contact anything, but it's just a measurement we wanted to be mindful of.
And something else that we have to be mindful of is the bell housing and also the headers, which obviously aren't on it right now. But the more that we lower the engine, the closer those come to the ground, and we need to make sure we have a few inches between those and the pavement.
All right, and one thing that we did notice is the stock cross member for the transmission should work. All we've done is flipped it 180 degrees and put this mounting tab on the back. We'll just have to cut this tab off, move it to the front, and that should get us mounted on the transmission side of things. From there, we'll get the front and the back mounted.
Yep, I'll start making some brackets for the motor plate. To keep things simple, I'll go ahead and cut out the brackets on the plasma table. These are pretty basic, and we'll have 2 holes on each side to bolt to the motor plate. I'm just going to tack these brackets in for now, just in case we have to move things at a later time. I'll transfer punch the holes so we know where to drill in the motor plate.
Now that we know exactly where the front of the engine mounts, we know exactly where the transmission is going to mount. It turns out that we can still use the factory cross member. We're just going to come in here and cut the mounting pad off of the back of the tube, and then we're actually just going to reuse the tube itself for the mounting point. That just entails a couple quick cuts and a couple holes drilled. With the bracket cut off, I'll drill one hole for our new transmission mount. All right, let's see how this thing fits. If we like it, all we have to do from here is drill another series of holes in the subframe rails, and then it'll be mounted, so yeah, I like that. All right, that should work for now. The engine and transmission are in their final resting spot. So from here, we're gonna take a couple measurements because coming up, we're gonna cut a giant hole in the firewall. The subframe is mocked up and ready to go. But first, we have to make a little space to accommodate our drivetrain. All right, so now that we have the engine and transmission in the subframe, it's time to get this thing fit underneath the car. Now, since we've moved it all back about 8 inches, we know it's not gonna fit in the opening or the stock opening here on the firewall and in the trans tunnel area. So it's time to make this big cut. Now, we have done a little bit of measuring. We know that we're gonna have to open it up somewhere around 18 to 20 inches. Plus, we're gonna have to take some depth out of it as everything slides back. Our heads, our intake, our induction will now all be up underneath this cowl area here. So we'll start by marking a line. We'll get this cut out. Then we'll transition into the car and we'll start working on the trans tunnel. This is just a basic cut for now. Once we get all the engine parts on the engine, we'll make our final cuts. Okay, so we've got the major cut up here on the firewall in this trans hump area. Now we got to work on cutting out the transmission tunnel itself. We have done some measurements and we know the back of the transmission is actually going to land way back here in the car. That'll put our shifter in this location somewhere, and that's kind of ideal because our butt or our seat is now sitting back here versus where it was sitting up front before. Now, one thing to note, this is a subframe car and there is a giant cross member that runs right here. That's where the subframe actually mounts to. We can tell that because of these little plug welds or these factory weld spots in here. So once we get into this area and start making our cuts, we know we're gonna have to spend a little more time because we're gonna have to cut through that. It's not a big deal right now. We will come back and re-strengthen this back up. One major concern with that is we bolt the subframe under the car and we set the weight down technically on the subframe, it could really push the floor up in the air, so we have to do a bunch of supporting here when it comes to that time. We're gonna end up making our cut quite a bit higher on the transmission tunnel area. We're gonna leave this flange here and it's just gonna help us build our new transmission tunnel off of that. It gives us a nice flat spot to work off of. So we'll go ahead and lay a mark down. We're gonna start cutting, then we're gonna take this whole thing out as one piece.
Somewhere in this area, again, this is kind of all somewhat of a guess, somewhat of a mathematical line, but
Just a real basic cut. All right, this is exactly what I was talking about. Now that we cut this giant cross member out of here, The floor has become extremely flexible. It's kind of lost all its rigidity, so we will have to come back and rebuild this a little bit later. One other thing to note is now that we have this giant hole in here, you can almost tell that the transmission is going to be a little too wide, especially back here in this crossmember area. We may have to do a little more trimming, kind of come up in this area and maybe even just get rid of these flanges. But for now, what we're going to do is get the subframe up underneath the car, try to get it bolted into position, and we'll see what happens from there.
To mount the subframe in our car, we went to Summit Racing and picked up a set of these RideTech solid subframe bushings. These are made out of Delrin, so they're a lot stiffer than the stock rubber ones, and they are the stock height, so when you go to put your subframe back in your car, all the geometry and everything should remain unchanged. And why these are important for our car specifically is because in a race car, you want the suspension to do the work and not have any flex between the subframe and the body, so these are going to do a great job constraining everything. So if you need to mount a subframe in your Camaro, go to Summit Racing and pick up a set of these.
We're installing a set of Goonie wheels to help us roll our subframe under the car. These have airless polyurethane rubber tires, can hold up to 3,500 pounds, and have a universal bolt pattern that fits most cars and light SUVs.
I'll grab the shifter in here. Let's see how close we are.
Let's see here.
Ooh, tight fit. Keep coming though. Wow. That's going to be close right there.
Actually, we got to come forward a little bit, so it looks like it'll fit.
That does fit. Wow, perfect.
All right, let's get this guy up to the mount holes.
All right, I got this one started.
Yeah, same here.
Get the back ones going too. All right, Michael, you can lower the car down a little bit now.
All right, that does it for the front. We're gonna move on to the back and make this thing a roller. Coming up, we show you what to look for when measuring for a set of custom wheels for your ride. To make our Camaro a full roller, we're gonna go ahead and put these hubs on. And before we get the other set of Goonie wheels on, we are gonna measure for our actual wheels. So I'm just gonna go ahead and get this on here. Not gonna grease the bearings because this is just purely mock-up. This car will go together and come apart probably 3 or 4 more times. So just go ahead and get this thing buttoned up on here. Also going to put the drive flange on just so we get the right offset of the wheel. And the brake rotor mounts to the back of the hub so we don't have to worry about mounting the rotor hat or anything on this. We're going with a 3-piece wheel setup on our Camaro, and we want to make sure we get the specs right when we order it. And this is especially true if you are going with a more expensive wheel because you want to make sure you get it right on the first shot. So we went to Summit Racing and picked up this WheelWorks wheel offset measuring tool. It's easy to set up to your rim diameter and your width, and then you can adjust the center section to different backspace settings and put it on your car and test it. So I'm just going to put this up here and see where we're at. All right, so I kind of expected this. The tire's hitting the leaf spring, and that's where we're limited for this. So I'm gonna have to adjust this plate to give us a little bit less backspace and push the tire out. So with this tool, there's a couple bolts here that we just have to loosen up real quick. That way we can move the center plate, I guess, in comparatively to everything else. We'll get this up against the drive flange and we'll put some lug nuts on here just to secure it. And this tire now is sticking outside of the quarter panel, and that's okay because we are gonna flare this a little bit just to get everything to fit. So what I'm going for here is just getting maybe a 1/2 inch off the leaf spring because this tire here is a 335, the one we will run is a 315, so it'll be a little bit skinnier. So I can just about fit my finger between the leaf spring and the tire, which is pretty good there. All right, so according to our tool, we're looking at 4 inches of backspace, but we have to subtract a 1/2 inch for that big mounting plate in the center. So our overall wheel size would be 18 by 11 wide with 3.5 inches of backspace. So now if you were doing the front, it's a little bit different because you have to run the steering through its full range of motion to check for clearance, and you have to have it at ride height, which is why the setup rods are nice because we can keep the suspension compressed. Obviously in the back here, we're sitting up on the spring, but we're not too concerned about clearance vertically or in the wheel well. We're just concerned about clearance laterally to the leaf spring and the fender here. And just out of curiosity, it's probably sticking out about 1.5 inches, and we do have a way to take care of that later on. But for right now, I'll just get this off and get our wheels ordered.
Up next, we want a little more protection in case of an emergency. So we'll assemble a stylish rear firewall to give some much needed safety.
All right, guys, we've got our Camaro sitting on the ground. It's basically sitting on its own weight now. So now we're going to turn our attention to the inside of the car. We've cut the firewall for the front. Now we're going to move our way to the back.
And what that entails is actually building a firewall in the rear of the car. What that's going to do is going to separate the fuel system back here in the trunk from us up here in the passenger compartment. That way, just in case there's a fire or a problem, gives us a little more time to get safely out of the car. Now, we're not going to be doing it the way Jimmy does it with his CAD programs and the CNC machine, but we are going to be using CAD. This is a little more old school. It's called cardboard aided design.
Kind of takes me back to kindergarten.
All 3 years?
All 3 years. At least I graduated.
Right.
We'll do a base cut in here somewhere, and then we'll come up here to try to follow the wheel tub, something like that.
The best part about using cardboard is it's easy to make adjustments with. Plus, if you screw up, you can just grab another piece.
I fit pretty good on my side.
I'm pretty good on mine.
Okay, so I think from here then we'll build out the framework. We'll use some square tubing, build the framework, build kind of a package tray, and then we'll come back and finish these pieces off in steel.
All right, sound good.
We're going to use a piece of 1/2-inch square stock to build out the framework for our firewall.
Before Jeremy can put the rod in place, I'll go ahead and prep the area for welding.
All right, we'll cut a vertical here. Let's go 14.
14, yeah, looks good. Go.
We'll trace our patterns out on a piece of 16-gauge sheet steel and then just trim it to fit. All right, we'll do a little test fit here. Then I've got an idea how to give this thing some style. Yeah, that fits really good. All right, let's give it some style. You may have seen this on the car before, but to give it some style, we're gonna be using dimple dies. We'll start by cutting some holes in the firewall that match the size of our die. Then head over to the press and add the dimple. We got these from Rogue Fab, the same place we got our tube bender. We'll use these little covers here. We'll cap this off that way. It can still be a functional firewall. All right, we'll do one more test fit here. See how this looks. Yeah, that looks really good. Now all we have to do is repeat the process on the other side. Not only do the dimple dies look cool, they also add strength to a flat piece of steel. All right, guys, well, we have all the pieces made in the back here. We even made this top plate. We're gonna call it our package tray, and that pretty much buttons up this rear firewall.
And what that's going to do is in the event of a fire, it's going to allow us more time to exit the race car safely.
And now we can get these panels out, get everything prepped, and then tack it in.
Today on Carcass, it's all about trimming the fat. But first, we gotta work on some of those curves. We'll show you a method to add some flair to your project's body panels.
Then we'll shed some weight using a low density material that you can mold into multiple forms and is exceptionally durable. What's up, everybody? Welcome to Carcass. Today on our road course Camaro, we're going to be making some modifications in the performance and the aesthetic department. On the last episode, we got our rear wheel fitment down and the tire sticks out about 1.5 inches, which is okay, but we need to find some way to cover it up. Otherwise, it's going to look goofy sticking outside the quarter panel.
And we could use the traditional metal flare, but instead we've decided to make our entire quarter panel out of carbon fiber. And what that's going to do is it's going to save us weight and give us a better look. What we need to do first is shape our flares here so we have a mold to lay our carbon fiber on.
So for right now, we're just going to prep the panels with a DA sander, and then we'll show you a really cool material that's very easy and fast to make complex shapes. I'm going to grab the sanders and we'll get started.
All right.
We've got the quarter panels prepped, and now I'm going to give a game plan as to what we're trying to do. To get the shape of our flare, we're going to be using a 2-part expandable foam. You just mix these two together, and then it should expand to 18 times its liquid volume. And this stuff is really awesome because once you get it on the quarter panel, it's really fast and easy to make very complex curves with just some basic tools. But the problem is we need to find some way to contain the liquid while it's expanding. So we're just going to be using some cardboard. And then we took a hot glue gun from our paintless dent repair kit, but anything from your local hobby store or arts and crafts type store would work just fine. And so we sanded the panel just to give the foam a little bit of bite, but there's no real science to this, so we're just gonna start cutting and start gluing. Get some glue on there. Just let this dry for a second. The goal with the cardboard is to make the foam structure bigger than the final shape of the flare. That way we can slowly remove material until we get the desired shape. The foam is mixed in a 1-to-1 ratio, and we have only about 60 seconds until we have to start pouring. Then we wait.
All right, ready for the chaos?
All right, so obviously we had a little bit of a leak. Good news is with this foam, there's now no leak because it expands and fills the gap. So we were gonna do this in 2 pours anyway, so just gonna get the rest of this done and then we can peel everything off, see what it looks like. All right, so now It's best if you can kind of pull the tape and the cardboard off while this stuff is still warm, because if it fully cures, then you're gonna rip the cardboard and it's gonna get stuck to the foam, and it just makes more of a mess than if you can get to it early on. I have the foam on the quarter panel, and now it's time to shape it. And I'm pretty much going to do that with only 2 different tools. This is a reciprocating saw blade with tape as a handle. This is a die grinder with a scuffing disc, and these are just going to mow through it. This makes an absolute mess, so if you don't want dust on something, now's a good time to cover it up. But otherwise, we'll get this going. As you can see, I've removed quite a bit of foam with the saw blade and the scuff disc, and then I went over it with some 36 grit sandpaper to take care of some of the sharper edges and just smooth this thing out. So at this point, what we have to do is do the final shaping, and I'll go ahead and smear this entire thing with body filler, and then we'll really focus on trying to make a smooth transition up onto the quarter panel. And another thing I want to focus on is retaining this kind of vertical edge all the way around the wheel opening. That's really just going to define the whole thing and give it kind of a factory kind of lip here, and that'll look really good when it's all finished. So I just have to mix up a ginormous amount of filler and smear this whole thing. I mixed the filler in several batches just so it wouldn't start to cure on me before I could get it onto the flare. All right, so I've got this shaped using 36 grit on a block. I'll probably go up higher in grit just to get this a little bit smoother, but we're ready to move on to the next steps, which is priming this and then making the fiberglass mold.
Up next, we start the process of making the fiberglass molds on our 72 Camaro race car. All right, guys, well, we have both sides of the Camaro basically matching as far as the bulge goes on the quarter panels here. We've gone through the foam, we've done some body filler work, and then we put both sides into primer. What I'm doing on my side is just hitting down the primer or knocking it down with some 400 grit. What Jimmy's doing on his side of the quarter is he's actually applying some wax. Now, I know it's really odd to be waxing over the top of primer, but there's a specific reason he's doing this. As we move on to the next step, which is the fiberglass, we're gonna wanna make sure that that fiberglass mold can release from the car and not have any issues. Now, this isn't the only thing he's gonna be doing to help it release, but while he gets this side really slicked out, I'm just gonna keep sanding on my side.
I'll go ahead and hit this quarter panel with 2 to 3 coats of wax before brushing on some PVA release agent, which will also help aid in the release of the mold. The type of wax we are using is specific to composite part fabrication and mold making. However, you could use other types of wax for this. The PVA is meant to be a thin film, so we'll go ahead and spread this out evenly. Next up is the gel coat, which provides the tooling surface of the mold, and this needs to be applied in 2 thick coats. We've got a few coats of gel coat on the quarter panel now, and this stuff has cured for quite a while. We had a little bit of an issue with some wrinkles up here, and we think it may just be a variation in the thickness, because this stuff is pretty sensitive to how thick you can lay it on the panel, especially when brushing. This isn't a big enough problem that we want to peel all of this off and start over, and we can fix this later on. So for right now, we're just going to start cutting some fiberglass, kind of lay it out, and then we'll get some resin on it. We are using chopped strand matte fiberglass along with a polyester resin. When the polyester resin gets applied, it breaks down the binder in the mat, which makes it extremely pliable to form around complex shapes. To saturate the mat with resin, it's best to use a stippling action with the brush instead of trying to use brush strokes, which can separate the mat and make a mess.
Okay, so with this chopped strand fiberglass, there's one trick if you're using two pieces, which we didn't have to do two pieces for this panel, but we just wanted to illustrate how this works. If you have two pieces that you need to overlap, it's best to rip the edge. That way when they lay against each other, they kind of lay into one another and form kind of a flat transition, versus if you have two pieces that are overlapped, it's just going to double your thickness and that transition's going to be a little bit funky. So ripping it is the best way to do it. I'm good up front here. We've got 4 layers of fiberglass on the 2 coats of gel coat, and we've let this cure for 24 hours. And now we can try to pop this thing off and see what our mold looks like, and hopefully we get a clean release.
There you go.
We got our fiberglass mold, so I'm going to trim this up and we'll start laying some carbon. Coming up, we show you a few methods on how to make super strong carbon fiber body panels. I'm just about ready to make some carbon body panels for our 72 Camaro race car, and I'm going to be using 2 methods to do so. Method number 1, I'll be using the mold of our passenger rear quarter panel, and method 2, I'm going to be using the actual door off of our car. And the main difference between these 2 methods is basically how much work is on the front end versus the back end. When you're using a mold, of course, you had to make the mold using gel coat and fiberglass on the front end, but on the back end, you really should just be able to pop the panel out, trim it, and you're done. However, the other method, we're using the actual door, so there's no real prep work involved, but at the end, we're gonna have to finish the outer surface to make it look nice. One thing that is similar between these 2 right now is they have a few coats of wax and a few coats of PVA release agent. So right now, I just have to cut the carbon and we'll start laying it in.
When cutting carbon fiber, make sure you have a nice sharp pair of scissors, and also cut your pieces a little bigger than the mold and trim accordingly. I try to shoot for about 1 inch to 2 inches of overhang all around. The resin we're using for the actual body panels is epoxy based. We mix this 4:1 with the specified hardener.
Mixture up. All right.
We'll use spreaders to saturate the fabric. We're using 2 layers of carbon fiber and 1 layer of fiberglass. There's not much of a weight difference between the two, however, we want the look of the carbon fiber on the outside. Another benefit of using both carbon fiber and fiberglass is that fiberglass is much cheaper than carbon fiber fabric, which will help lower the cost.
All right, we got the quarter all saturated with epoxy, so we're gonna let that cure and we'll start working on the door.
With our carbon fiber cured, now we can start bonding it to the panels.
All right guys, so we've had some time to let these body panels cure. So we're gonna get the quarter panel out of the mold, get the door skin off the door, and once I pop this, you'll see just how different it is. All right, so we got a pretty good release there. And as you can see, this surface is perfectly smooth, or it just takes on the surface of the mold. So all we have to do to this is just trim it up, wash the PVA off, give it a quick sand, and then we'll clear coat it. But for the door, let's get that off and take a look. All right, so there's our door skin. The door wasn't really damaged at all, but this surface now, it's got the texture of the weave of the carbon. So now what I'll have to do is actually use epoxy to level this entire surface, and then we'll go and use the epoxy and kind of body work this panel to make sure it's straight. And that's really the downside is, you know, there's really no prep work up front, but you have to spend a lot of time sanding this thing to get it straight. So actually the easiest way to do that is to get this bonded to the door, because obviously you can see this is super flimsy, but once we bond it to the door, it'll give us a nice rigid surface to sand against. So I have to cut this skin off, gut the door, and then we'll get this panel bonded on.
The doors are put together by having the door skin's edge rolled over onto the door frame. So I'm just grinding until I can see 2 distinct layers of steel, and then I'll move on to the next section. I've got the door skin separated from the door frame, and there's a couple interesting things about this now that it's apart. The first one is just there's a lot of rust in the lower portion of this door, and the more interesting thing is that there's a lot of these little holes that have been filled with body filler. And the reason why that they are there is because this door must have gotten punched pretty hard, and the old school dent pullers, you'd have to drill a hole in the panel, use a tech screw and a slide hammer to pull them. So this door's been wrecked pretty good, along with a lot of the other body panels we've been noticing on the car. Again, it just goes to show this car is a really good candidate for a race car, because if you wanted to do some high-end build, all of this stuff would have to be replaced anyway. So I'm gonna get the door gutted, and then we'll get to bonding. A lot of the weight inside the door comes from the side impact bar, and once I cut it out, I'll go back and just grind the sharp edges smooth. Then I'll flip the door over and cut the inner portion of the door frame, as the window will no longer be there and none of the other components need to be installed. To bond the carbon skin to the door frame, I'm using windshield glue, but you could use any type of panel bond to do this as well. So now we're on to one of the last steps, which is pouring more epoxy on top of this panel. It's going to be the same epoxy that we used for the fabric. So we're just going to lay some on here, and there's no real trick to it. It's going to kind of run off the panel, but we just need to build up some thickness so we can come back and sand everything smooth. I'm using a modified spreader with some teeth cut in it, which will somewhat spread the epoxy, but not completely wipe it off the panel. The epoxy on the door skin here needs to cure, and then the final steps will be to sand it and give it a final trim to fit the car. And then it will look like this driver's side door, which is finished. It's got that nice carbon fiber look, and it's all slicked out. And these doors used to weigh somewhere around 115 pounds, and now they're down to the 30 to 35 pound range, which is a huge weight reduction. We also have a bunch of other parts in progress, like the passenger side front fender, the rear quarter. I've also got the deck lid here, which isn't just a skin, but it's also the underside structure. So this thing is nice and rigid, and I bet this thing doesn't even weigh 5 pounds. So when it's all said and done, I think we'll have saved maybe 500 or 600 pounds. We've got a bunch of other parts to do, the hood included, which is a huge piece. And that's gonna be a huge performance benefit, and I think we'll see the results on the track. But in the meantime, I've got plenty of work to do, so I'm gonna get at it. Today on Carcass, we make our 1972 Camaro a hardtop once again. But first we'll show you how to remove the glue and remnants from the old vinyl top.
Hey guys, welcome to Carcass. Now Jimmy and I are super excited to get our hands dirty on our 1972 road course Camaro again. It's been a hot second since we've touched this thing. Now we've done a bunch of work so far to get it to this point, but if you guys are just joining us for the first time, or you just need a quick recap, let us show you what we've done. We started with a well-used, stockish Camaro RS that had some really good bones. We got to work stripping it down to just a shell so we could see what we had to work with. After finding a couple issues, we dug into the body and added a set of mini tubs so we can fit up some wider tires, along with a fuel cell in the trunk. Then we laid out the groundwork for a race-inspired roll cage to stiffen up the car and to keep us safe.
The next thing to do is add some upgraded suspension in the rear, along with a 9-inch axle to handle the horsepower. Up front, we cleaned up the subframe, did some mods, and replaced the suspension with some tubular upper and lower control arms.
The engine and transmission install came next, which included moving it back about a foot and adding a front motor plate. To get it to fit in the Camaro, we grabbed some cutoff wheels and trimmed the firewall to fit. Then we added a rear firewall to block off the fuel cell from the passenger compartment.
The last thing we did was lay out a set of custom quarter panels and fender flares to fit our wheel and tire setup. That included some work with some expanding foam, body filler, fiberglass, and most importantly, some carbon fiber. All that work leads us to today, and something that you guys may have noticed over the last episode or so, that these panels have made their way into the main hoop structure. The reason why I made these is just to give the interior of the car a little bit more of a finished look. So I made these out of some aluminum sheet metal, gave them a bead roll pattern just for some rigidity and some style, but they aren't quite done yet. I will have to cut some holes in these two panels just so our harnesses can attach to the harness bar. And you also may be wondering, how are we gonna see out of the back of this thing with these panels blocking our view? We are gonna be using a rear view camera like a modern race car would. But all the work on the inside that I wanted to get done with the roof off has now been completed, so we can finally get the roof back on the Camaro.
Now with the cage work and the panels that Jimmy just showed you installed inside of the Camaro, now is a good time to weld the roof back on the car. Now we know we gave you guys a little bit of a heart attack when we cut this off, but it allowed us to weld all of the seams on the Camaro's roll cage to make it nice and safe. If you guys remember when we picked up the Camaro, it had a vinyl top on it, and when we pulled that off, it left all of this fuzz and all of the glue on the top. So now is a good time to tackle this and get rid of all of that fuzz before we weld it on, just because it's sitting here on the table. We have a couple different ideas on how we're going to tackle this, some techniques that we're going to try. Let me go grab some stuff, and we'll show you how we get that done. So one of the methods that we could use to try to get the glue and the fuzz off of the roof here would be to use a DA. Now we don't think that's going to work very well, because as we start sanding into the glue and the fuzz, we think it's just going to load up the sandpaper. Sandpaper is expensive, just doesn't seem cost effective to do it that way. Second method includes a Scotch-Brite, and we could just sit here and try to rub on the fuzz itself to get it off. Just doesn't seem like that's working either, and it's kind of loading up on the Scotch-Brite already. Third method involves just a rag and some lacquer thinner. So if we kind of saturate the rag here a little bit, we can set it on top of the glue and kind of hold down on there and just kind of let it chemically react and release some of that glue, and then come back and try to rub it and wipe it off. That seems to be doing the job. And the fourth method, which we think is going to be the quickest, is to use a grinder with a bristle disc. Some people call them a roll-lock disc. And we could sit in here and just grind all of the fuzz and the glue off. Now, our plan is to use a combination of both of these. What we're going to do is soak our rag full of lacquer thinner. We're going to let it rest on the fuzz and on the glue for a little while. Then we're going to come back, grab the roll-lock disc, and we'll start taking all this off and get this whole roof skin cleaned up. So let's go over a scenario where you guys do want to keep your paint in good shape as soon as you get all of this stuff off of here. We figured it out. If you use your rag that's soaked in lacquer and you just let it sit on the panel for a couple of minutes, it actually does a really good job of releasing all of the glue. And if you rub it, put some elbow grease into it, you can actually just rub all of the glue, clean off the roof skin here, and let you save your paint. But we're going to keep moving forward. We're going to use a combination of both of these. We're still going to use the lacquer and the little angle grinder there. We're going to go ahead, get this all prepped, taken care of. Then we're going to move on to getting this thing welded back on the Camaro.
Coming up, we show you how to remove old lead body filler. Then we put the roof back on our road course Camaro.
All right, so we have the top prepped and it's ready to be welded back on the Camaro, but there is one thing we have to take care of first. Now, when Jimmy and I cut the top off of the car, we cut right through the factory seam, and what GM did and what a lot of car manufacturers did is instead of using a body filler in here to make this all nice and smooth, they actually used lead. Now, there's two ways to get the lead out of this thing. One is by grinding it, but we really do not want to make it airborne. And the second step, which is the way we're going to be doing it, is we're actually going to be using an oxyacetylene torch, and we're going to be reheating up the lead and making it flow. And then we're going to go ahead and use some scrapers and maybe a wire brush here, and we're just going to kind of brush this off and let it hit the floor. Now, one thing I can't stress enough here is your personal safety. Make sure you've got a good pair of glasses on. We've got good respirator, gloves, and I'm even going to be wearing a jacket. Plus, we have an exhaust fan here in the shop, so we're going to turn that on, make sure we pull all the fumes up and out. So, to get started here, I'm going to get all suited up. We'll fire up the torch, and we'll literally try to get the lead out. When you're doing this, you want to make sure you move around the panel a lot. We don't want to put a lot of heat onto the panel to the point where it starts to distort. Just heat it up enough to make the lead run off. Okay, so now all the lead is out of the back of the car. We're actually going to transition up here to the A-pillar. What I've done is bent up a couple tabs that fit the contour of the A-pillar on the inside. The idea behind these tabs is we're going to drill a couple holes and do some rosette welds and keep these tabs into place. Then we're going to come back, and when we set the top on, we're going to engage the other side of the A-pillar into these tabs with a couple rosette welds, and we're going to weld it on that way. Then we'll also come in and weld up the seam. Now this is a nice, strong repair on the A-pillar, but one thing to remember is that the top is just solely for aesthetics at this point. It's just to make the car look like a Camaro again. Our roll cage is doing everything we need in the safety side of things and just to stiffen up the chassis. So we'll go ahead and get started here. I'll pull the tabs back out, grab the drill, and we'll drill some holes for our rosette welds. Once the holes are drilled, we'll remove all the paint to give us a nice, clean welding surface. All right, so we got Jimmy on one side. I grabbed Joel from Detroit Muscle. He's gonna hold the back, and we're gonna try to engage the A-pillars into these tabs. All right, I got mine started.
Let's see.
Pushy pulley here.
Yeah, I'll just need to kind of tap these with a hammer to get them to fall in.
Okay, I'll grab a hammer. All right, mine's in. Perfect. There we go, that'll work. With a combination of rosette welds and stitch welding, I moved around the car, making sure I didn't weld in one place too long and distort all the metal.
It's full-on fabrication today on Carcass. We'll cut out the quarter panels on our 72 road course Camaro to make room for the new carbon fiber panels. We'll install a few key components for the fuel system, plus show you how we attach our new carbon fiber trunk lid.
Hey everybody, welcome to Carcass. This is our 1972 Camaro that Jimmy and I are turning into a road course race car. We've done a bunch of work on this car already, and most recently, we've welded the roof skin on this so it looks like a Camaro again, and that's gonna kind of take us down our path we're going on today. We're gonna start working on some body mods.
And so today we're gonna be focusing more on the rear of the car. We have some carbon fiber quarter panels that we've made already, and I've mocked one up on the passenger side. So I'm gonna show you how I did that on this side here. We also want to cut out a polycarbonate sheet to replace our rear glass, and we'll show you how we mount that. And we also have the carbon fiber deck lid, and we want to mount that and still make it functional so it hinges like the stock one would. But for this right here, I'm just going to start with some tape so we can figure out a cut line. Before we can get the new carbon fiber quarter panels on here, we want to get rid of the old steel. I'm using the tape as a guide to figure out where I'm going to cut, and I'm making sure to keep a 1/2 inch to 1 inch of sheet metal that I can rivet the quarter panel to. All right, so we've got this thing taped up. I've got a hole drilled, and I'll explain why I'm doing that. When we go to cut this, it's best not to have sharp corners up here just because it leaves the metal more prone to cracking, especially with this thing vibrating so much. We just want to make sure these are nice round edges so it's less of a stress point. And then these lines may change depending on how we fit up our carbon fiber quarter, so these aren't like the end all be all. If we want to grind and trim some stuff to move the lines back a little bit farther, we can do that too. Okay, so I have the quarter panel mostly cut out, but to fully release it, I actually need to get to the corner of the stock wheel lip. So, you know, everywhere along here I need to grind so that the sheet metal releases. And to get to it, I need to get all this foam back off, or at least some of it, so I can get a grinder in there. So I'm just gonna take my screwdriver, shove it in here, hit it with a hammer, and just try to crack it off. The reason why the foam was on here in the first place is because it was used to shape our fender flares, which gave us the plug to mold the carbon fiber quarter panels. With the quarter panel removed, I'll start removing the paint on the edges so I can get a really clear view of what I'm working with. Got this rear quarter panel cut out now, and I've got this kind of trimmed out, got these sharp edges taken care of. A couple things here about this is I'm probably gonna end up coming back and cutting this way down, possibly cutting this entire lower section off and bracing it from the chassis to our new quarter. And the other thing too is that with this inner fender lip here, with our wide tires, if I left this, it would end up cutting our tires. So at some point we're gonna come back, cut this entire section out. We've got our carbon fiber quarter about 90% trimmed, which is good enough to fit this up right now. We're gonna put some Clecos in it, so I have to drill some holes.
What do you got for a gap? You good?
Yeah, I'm good here.
Nice, these things are so handy.
Yep, I love them. So that's pretty much it to get this quarter installed. Still got a little bit of trimming to do, but as you can see, this thing's really rigid up against the car, and I think that's gonna work out just fine.
Up next, we'll show you a few tips on what to look for when installing the fuel system for your race car. Jimmy's got the carbon quarters installed on the Camaro, and we did strip off all of the paint to give us a nice clean surface to work with. Now, since we're in the back, we're gonna continue on with our fuel system. We already have a hole cut in the trunk for our radium fuel cell. Now we just have to work on getting the fuel into it. Now, Radium also sent us what we need to hook up a fuel neck to the fuel cell. They sent us this little 45, this goes on top of the cell itself. And they also sent us this really cool, sleek fuel neck. Now, two things to consider when you guys are looking for a location to mount the fuel neck. One is the drop, or the angle of the tube as it goes into the fuel cell, and the second one is location. We're gonna mount ours up here on the quarter, and on the back side of this filler neck is this little foam pad. Now, the best part about this pad is you guys can mount this on a little bit of a curve, which works great because our quarter has a little bit of a curve here, so this should seal everything up. I gotta take a couple measurements, we're gonna drill some holes, and then we're gonna work on putting the fuel tube in itself. All right, so before we put the neck in here, we're gonna go ahead and use this deburring tool. I'm gonna take the sharp edge off of the ridge here. And then we'll go ahead and set this in place. Try to keep the handle here straight with the car. We'll mark these out and drill these out as well. right, so we can go ahead and put the filler neck in. We will put that little piece of foam on there. And drop in a couple of the screws, and then there's this retainer ring that goes underneath. And we'll tighten everything down. All right, now let's go to the filler tube. So up underneath here, we're gonna have to add this little 75-degree bend here. We got this one from Summit Racing. It's 1.5" OD, so it works with the rest of what Radium sent us. This will get us in the direction of the fuel cell. All right, so down here on the tank side, we'll add the adapter that came with the Radium stuff. Here's the other side of it. We'll screw this all down. And then we will add the piece of tubing that they also sent, and that should button all this up. All right, so then we'll go ahead and add the adapter on top of this piece, and then we'll pull a measurement from here, and then we can cut our tube. And that's gonna be 19. That side on, go to this side. This is just all mock-up. This is super easy to install. We got good drop on everything. All right, that works for the mock-up side of things. Radium makes some really nice products, and this will work perfect in our Camaro. So we'll call this all wrapped up here. We'll go grab a couple more things, and we'll finish out the back end of the car. Coming up, with other racers staring at our taillights on the track, we want to make sure they can see them. Plus, we'll finish up installing our carbon fiber panels on the rear of our Camaro. So we've been working on the back half of the Camaro, and one of the things that we are going to retain on the stock side of things is a set of taillights. Ours are in pretty rough shape, and we want to make sure people can see us as we're entering the corner, applying our brakes. Now, Classic Industries was nice enough to send us a brand new set of taillights for the rear. They've got the nice chrome trim ring on here, and the lenses themselves are crystal clear. This is a great option for you guys that are doing any restoration work, or it works great for us even on the race car side of things. Now, beyond all of the taillights and stuff, they did send us a nose cone and a couple bits and pieces for the front. Our nose cone was pretty beat up. Somebody must have got in an accident. So to get these installed, it's pretty simple. These just kind of unsnap from the buckets. We'll get them set in the buckets here. We'll install them in the car, and then we're just going to worry about the wiring a little bit later. Set these on here. They're a little specific on what side goes to where. Okay, let's get these set into place here. We'll bolt them down. To keep our new taillights and our buckets in place, we'll be using the factory speed nuts. These don't require a lot of torque, but will hold everything in nicely.
Next thing up on the rear end of our Camaro is to get the carbon fiber trunk lid installed, and I'm really excited to see this thing in its full carbon trim. But to get it on here, I have to get these hinges to lay all the way flat, and how they're held up is there's a torsion bar that's underneath this cover that just runs from one side across to the other. So I've got to get that cover off and get those torsion bars out of the way. Now, if I'm being honest, I don't really need these springs to be functional anymore, so the easiest way to get rid of them is to just cut them. And they're obviously under a ton of tension, so one way to keep ourselves a little bit safer is to put something really heavy over the top of them. And this is just a rubber welding mat. So I'm gonna go ahead and cut one of the springs here, and I'll wear the appropriate PPE. we should be good to go. All right, so now the next step is to figure out a way to get our holes transferred onto our deck lid so we know where to drill them for our rivet nuts. We think the best way to do that is to use paint pens, color the top of the hinges, put the deck lid on it and give it a nice press, and hopefully that paint transfers to the underside of the deck lid, and then we'll know where to drill the holes.
All right, you got enough on there?
I think so.
Yeah, let's try this.
And give it a shot. Line up the end, get our gaps right.
Yeah.
All right.
Think so?
Yep. Get the press on there.
Yeah. All right. See what happens. There you go.
There you go.
That works.
So we did end up putting a little bit of paper towel under here and put tape on it so it can kind of conform. That's gonna be perfect for us to drill some holes.
Nice.
Cool. I'm gonna get some drill bits and some rivet nuts. After drilling some pilot holes, I'll go ahead and drill to the final size for the rivet nuts. That is the install of our carbon fiber deck lid. This thing's looking really nice. Got about a 3/16 gap all the way around, which is perfect. Now we just need a way to latch this thing down. Now that our trunk lid is installed, we need a way to secure it. We'll show you a quick and easy way to keep it locked in place. With our deck lid installed, we need some way to keep it secure. And the way we're gonna do that is by using a latch system that you've probably seen on race cars before. These are Aero catch latches that we got from Summit Racing. And the way that they work is pretty simple. You have your latch here, you open it up, take your pin, go ahead and install it, shut it, gives you a nice secure connection. So with these, we have to mount the pin somewhere on the car, mount the latch onto our carbon fiber deck lid. So to get started, I'm gonna cut some metal. To mount the pins, I'm using 1/8 inch plate cut into a 1 inch strip. Got a strip of metal cut out that I'm going to use to make 2 L brackets. They're going to weld to the inside of the taillight panel, and then they'll each have a hole so we can mount our pin. Now I want to locate the pins somewhere in the flat areas here on the underside of the deck lid. That way when we mount the latch, we don't have to cut into the 3-dimensional structure of the deck lid, which makes it nice and rigid. So the way I'm going to locate that is I'm going to use my tape measure. Just measure from each edge of the deck lid, figure out where that's going to go, and then I'll measure just from the edge of the car and the outer edge of the deck lid opening. That way we can figure out how long our bracket needs to be and where the pin's going to be located. About 11.5 from the edge. After cutting the strip to length, I'll put a 90-degree bend in it to give some area to weld to. I've got my L bracket here with the pin bolted to it, and now I need to figure out where I need to weld this on the inside of the taillight panel. So what I have mocked up here is just a long ruler that kind of gives us a height gauge, and then basically I'm going to take our 10.5 to 11 inch measurement that I had on the deck lid, go from the 50-inch mark that I have on the left side. I'll go over to 39.5. Make sure the pin's about at the height of the ruler. And then I'll mark this so we know where to place it when we weld. Perfect. Now I'm back on top of the deck lid and I'm getting ready to trace out the template for our latches. And I did a couple things to help myself out. The first thing is I made a center line down the deck lid and then I picked a reference point. Then I used a straight edge to go from the hole to the reference point and I traced out the center axis of our latch. And what this does is I can then measure from each hole to our reference point, and I know that they're within a 1/16, so I know everything's going to be symmetrical and the angles are going to be mirrored. So now I can just use the hole and our center axis and I can line this up on the template, trace everything out. To get rid of the material in the deck lid, I'm using a hole saw to remove the bulk of it, and then I'll come back and trim it up to the line. There we go. That's one installed. I still have one more to do. Still need to finish welding these brackets and stuff on the inside, but we've gotten a ton of work done on the rear end of this car, getting all the carbon mounted. We still have some stuff to do, like the rear windshield, which we're gonna show you guys another time, but I still have a lot of work to do, so I'm gonna get at it.
Today on Carcass, we're rolling our 72 Camaro into the shop and we're gonna show you guys how we got this thing ready for SEMA.
And we're gonna mount some more carbon fiber components and show you how to measure for coilovers and shocks, so stay tuned.
Hey everybody, welcome to a brand new season of Carcass. Now Jimmy and I are excited to be working on a lot of different projects this year, but first and foremost is our 1972 Road Course Camaro. Now if you guys are just checking in on us for the first time, or you need a little bit of a recap, let us show you how we turn this rough around the edges Camaro into the race car you see before you. We started with a well-used, stockish Camaro RS that had some really good bones. We got to work stripping it down to just a shell so we could see what we had to work with. After finding a couple issues, we dug into the body and added a set of mini tubs so we can fit up some wider tires, along with the fuel cell in the trunk. Then we laid out the groundwork for a race-inspired roll cage to stiffen up the car and to keep us safe.
The next thing to do is add some upgraded suspension in the rear, along with a 9-inch axle to handle the horsepower. Up front, we cleaned up the subframe, did some mods, and replaced the suspension with some tubular upper and lower control arms.
The engine and transmission install came next, which included moving it back about a foot and adding a front motor plate. To get it to fit in the Camaro, we grabbed some cutoff wheels and trimmed the firewall to fit. Then we added a rear firewall to block off the fuel cell from the passenger compartment.
The last thing we did was lay out a set of custom quarter panels and fender flares to fit our wheel and tire setup. That included some work with some expanding foam, body filler, fiberglass, and most importantly, some carbon fiber.
Then it was time to tackle the top. We stripped away all the old glue left over from the vinyl. Next, we removed the lead that was used on the factory body seams. With the roof all prepped, we were ready to install it with the help of a couple friends. To make it go all smoothly, we added a couple tabs in the A-pillars to line everything back up.
With our carbon fiber cured, it was time to get them onto the car. We started by removing the old metal quarter panel, making sure to leave enough room for us to attach the new carbon skin. Once that was in place, we attached the new carbon fiber trunk lid and secured it into place with some race-inspired latches. Now that the top was back on, we fabricated some gussets, then welded them to the roll cage and the A-pillar of our Camaro, giving us some added chassis stiffening for better response out on the track. Now this past November, Jeremy and I had the really cool opportunity to take our car to the SEMA show in Las Vegas with our partner EBC Brakes. And so to get the car ready to go, there were a lot of things that we did that you guys haven't seen in any of the episodes, and we wanted to share with you guys some of the challenges that we faced in doing some of these things. And one of the biggest ones was just getting the front subframe ready to drop in this engine. So as you guys can see, the engine is sitting about 8 inches back from the stock location. And as we tried to test fit it with this giant dry sump oil pump hanging off the side, we ran into issues with the front crossmember. So as we started test fitting and chipping away at the front crossmember, we just decided it's gonna be easier to cut the entire thing out and build our own. So what was really cool about that process is we put the entire subframe up on a jig table. We located the lower control arm mounts, and then we just filled everything in between, made sure we had gussets in the right places to make sure this thing was really strong. Now moving back a little ways, you guys can see there's a lot of tubing structure in the engine bay, and that's because we wanted to tie in the roll cage to the front subframe. This makes the chassis and body extremely rigid and allows the suspension to work more efficiently and do its job properly. So we have 4 points of contact on the roll cage, and they come out to these 2 hoops on either side of the engine. Now Jeremy fabricated the firewall with some nice bead roll detail. We also made these plates to cover the holes that allow the tubes to come through as well. Now moving along onto the interior, Jeremy also fabricated the entire transmission tunnel and the rest of the firewall. And it was really cool to see this happen because I'm not too familiar with sheet metal work, so I was just trying to watch and observe as much as I could, and I really think he knocked it out of the park with this one. We've also been working on the driver ergonomics, mounting the seat, getting the pedals in place with a heel plate to make it a little more comfortable. There's still some work to do there, but it's well on its way. And there still are a few things that we're gonna show you guys at some point in the future, but that brings us to today, and we have a lot more work to do.
And now that you're all caught up, the next step is actually out here in the front of the car. The idea is to hang the core support up here on the frame rails, and then we're gonna be hanging a fender, because what we wanna see is how the wheel sits inside of the fender arch, because ultimately the goal here is to set up the suspension so we can get an accurate measurement on our coilover, and then we'll go from there, send those measurements off and have one made up. We're gonna go grab a bunch of parts, get all those in here and start setting everything up. Coming up, we hammer and heat our damaged brackets, showing you how to manipulate metal to retain its old shape. All right, guys, to get started up front, we need to start with the main structure of the front of the car, and that is the core support. Now, the reason why it's called a core support, the fact is that it does support most of the front stuff, like your radiator, and in this case, your air conditioning, and it also supports both of the front fenders. Now, our Camaro has definitely been in some type of an accident or something up front. We have a lot of bent brackets up here. There's big damage to the AC condenser, which isn't a big deal to us because we're gonna end up throwing that in the trash. And there's damage over here to a couple brackets, but that's nothing that we can't handle. We're gonna straighten all of this out. This being a race car, there really is no point in going out and buying a new core support, because all it's gonna do at this point is kind of help locate our 2 front fenders, and then we're gonna use the rest of this to help build out the front of the car so it looks like a Camaro again. I do have to get some of these brackets out of the way just so I can start straightening them out and get them on the table, use the flat surface here to really pound these back straight. And then from there, we're gonna probably hang some of the front on, maybe the nose cone, make sure everything is straight, and then we'll take this over to the car, get it on the car, and then we'll start hanging the front fenders. Okay, it's a good idea to mark all of your brackets, especially something like this where it could really be flipped over and go on the other side as well. So you just grab a Sharpie. What I do is I'll put an L on it for left, put an arrow that faces down, that way I know it goes on this side and it goes down. scrap pile. All right, so now that we have the brackets off, if we take a really close look at this center bracket or piece here, I'm going to assume that this should be completely straight. There's damage you can see, so I'm just gonna use the table to try to straighten this out the best I can. And as far as the side brackets go, if you look at the left bracket, it looks like there's no damage to it, so we're gonna assume this one's straight. But when you put the right side or the passenger side bracket up to the same spot, you can see that it's off and there's some good bends to it. So if we kind of try to match the two sides here, I can see that the ears are off the table. So I'm gonna assume that this one's bent, so we're gonna have to do some work here too. This one's a little more heavy duty, so we may have to use the vise, some bigger hammers, or even some heat to straighten this one out. But as far as the center one goes, it's just some, thin sheet metal, so we're gonna pound on the table here. Got the hammers and dollies. I'm gonna put my safety glasses and some hearing protection on. We're just gonna try to nail this thing straight. Then we'll put it on the core support again, and we'll try to test fit the nose cone. We'll use that to kind of block this side up so we don't bend that tab. And then we'll just hammer here and try to straighten this out first. Switch. So it's quite a bit straighter in there. Try to straighten this out then. Here's a little trick too. So if you don't have a hammer that fits in a certain spot to work something straight, your dolly works just as good as a hammer. You can pick that up and slam it down, find whatever works here, and use that to straighten stuff out, so. I'll try to straighten this out here, which that might just be a push. Maybe not. That we might just use the vise for. You could fit the vise in here and just use the pressure. So we'll try to straighten that out on the vise. So that's straight. We're gonna use that to our advantage now that it's in here. Because I think I gotta straighten it out here. So we're just gonna pull on this side to bring this up top, which I probably have to use quite a bit of force, but there. Actually, I don't know if you guys can see that. So as I pull here, you can watch this side straighten itself out. Like the metal is moving and it knows where it has to go. So as I pull this side over, watch that side actually moves back into position. So it's actually straightening itself out more and more the more we do. And you can see how straight this is now. So sometimes, as Bob Ross would say, happy accidents. A little bit that's left. We can move that into shape once it's back on the core support. So we'll call that a win. Let's see what we can do here. This bracket is made of a thicker material, so we'll use a little bit of heat to make the tab bend a little bit easier. When bending metal like this, you'll want to use steady pressure and be careful where you grab the part because this heat can travel a long way throughout the material. Ooh, that's warm. That's about all it wants to bend, so we're going to leave it right there. We use the power of pressure to finish straightening our core support brackets to install our new nose cone. All right, so the brackets are somewhat straight. The core support's somewhat straight. So we're gonna go ahead and mount this up here on the table. We'll get all the brackets on this thing, and then we'll test fit the nose cone and see how close we are. these brackets, we marked left and right and up and down, so I know where they're going. So now that we have the brackets on, the next step is to install the nose cone and make sure everything's straight. Now our old nose cone was damaged pretty bad, so we got a brand new one from Classic Industries. This is made from a high impact urethane, and probably the biggest point for us is the fact that it's straight, because our old one was in pretty rough shape. Now when we hold it up here, we can already tell that it doesn't fit in between the brackets, and I'm pretty sure we know why, and there's a bunch of damage on this side, but we're gonna try to prove that point right now. So Jimmy brought in a straight edge. What we're gonna do is assume that this bolt hole in the top of the core support is centered, and we're gonna use the straight edge to make sure that it does show that the left side's in better shape than the right side. So if I hold the nose cone up to the left side bracket, and Jimmy holds that straight, we can basically tell that this leading edge matches the peak of the nose cone, so we know that the left side is in good shape. And that pretty much proves the point, because this side is what we did most of the work on. Now, I can't move anything on this side. The way that it's mounted to the table is just gonna move around too much. So from here, what we're gonna do is take the core support off. We're actually gonna go put it on the Camaro, and we're gonna use the mounts for the core support on the frame to make this thing rigid. And we'll do a little bit of pushing and pulling, basically over here on the passenger side or the right side, and get this all to fit in there. So that's pretty much the next step. We'll get this thing unscrewed. Jimmy and I will take it over to the Camaro, and we'll get it all set up. Okay, so we have the core support sitting on the chassis rails. We've got the body mount bolts in and kind of holding it loosely into position. And I've got this kind of hydraulic ram in here. It's called a porta-power or a porta-brace. What this does is it's just going to use a little bit of hydraulic pressure when I pump the handle and use the ram here and kind of shift this bracket out. Now, if you guys don't have something like this, you could easily do it with a pipe or a bar, find a way to get in here and pry and just pull it over. But we're gonna use hydraulic pressure. We're gonna go nice and easy on this, and then we'll do a test fit with the nose cone to see how much movement we've gotten out of the bracket, and we'll see if it works from there. So, we'll just do a couple pumps here. I'll check the nose cone once. Make sure it fits inside. Once I've got it fitting, I will actually go past the point I need to let it all kind of relax back, because it's going to kind of spring back, if you will. So we have to go quite a bit, actually. So even by doing it this way, we're almost there. By doing it this way, I'm actually using the bracket and maybe changing some of the damage that could be actually in the core support itself. So, so past a little bit, and I got to do some tweaking here, I can tell already, but let's see here once I take it off. Well, that really relaxed. May have to do this a couple times, but we'll get it. Top's good. Push on the bottom a little more. Try to shift the bottom. Top's moving too, but use a big pair of channel locks. We're gonna shift the top back. Leave the pressure on it to help move these brackets around a little bit, so it's kind of twisted. There we go. Yeah, now we just gotta get it to stay there. So I'm gonna go way past. Let it relax for a second. See where we are. Oh yeah, right there. Look at that. That's almost perfect. Grab some bolts and put the nose cone on. All right, nose cone's on, fits. Now we'll just move on, get a fender on this thing. All right, so we got the fender on the car, core support's in it. We just had to tweak the core support forward just a little bit, not a big deal. The other thing that we are running into is the actual steel structure part of the fender is sitting on top of the tire, so it's not allowing me to push the fender in completely. We knew that was gonna happen, and we do have a solution for it.
Coming up, we fix our fender problem and measure for a set of coilovers. Jeremy has the core support mounted on our Camaro, and like he explained, the fender doesn't really fit because the tires are so wide that they hit the underside structure. So what I'm going to do now is go ahead and cut some of this fender structure out and get our carbon flares put in place. And just to give you guys a little bit of a recap, the reason why we did the flares in the first place is just so we could have a wider track width and still be able to tuck the wheels and tires underneath and make it look really nice. Now, one big benefit of using some of this fender structure to mount our flares is that we retain the stock mounting points of the fender, so it goes right back on the car. We'll get some rigidity once we rivet everything together, and also we retain the headlight bucket geometry, which allows everything just to go back in its original place. So of course, there's going to be some weight savings by cutting this out, putting the carbon on. It's probably going to be negligible, but I think this is a nice compromise of making it a little bit easier to get our flares onto the car. To cut the fender structure out, I'm going to start with a hole saw. This will give us a nice rounded edge to prevent any stress risers. Then I'll cut the rest out with a cutoff wheel. All right, so I've got the fender and our carbon flare roughly trimmed. So at this point, what I'm gonna do is go ahead and drill some holes. We'll get this thing clecoed on there, and then we'll go ahead and get it back on the car, test fit everything, and then we can measure for our coilovers. All right, got these two clecoed together. We'll see how everything looks. I've got the fender on the car and fitting the way that I want it to, and I can see already that it's just a little bit too low, so we're gonna go ahead and jack the car up and get our setup rod maybe a 1/2 inch to a 3/4 of an inch taller, and then we can take a measurement, send them off. All right, so I've adjusted the setup rod, and we'll set the car back down on the ground and get a look to see how it's sitting here. It's got a little bit of rake on it still, so I think we're good.
All right, take a measurement of the rod. Top of bushing to top of bushing's about 15 inches. It's 14 7/8, so that's close enough. So what we're gonna do from here is take this measurement, we'll send it off to UMI, and they'll just whip us up a set of coilovers. But we did get accomplished what we set out to do, so that'll pretty much wrap it up for us today.
See you guys next time. I gotta get the other fenders made too.
Yeah, you can get the quarter and stuff on it.
Yeah.
Get the jacket stuff out of here. Today on Carcass, we'll show you how to fabricate a custom dash on our road course Camaro so we can install our new gauge cluster. Plus, show you another way to wire up your project that is just plain clean and simple.
Hey guys, welcome to Carcass. Jeremy and I have done a lot of work on this car that you guys haven't seen, and some of which we think is really cool, so we want to go over a few details on some things with you guys. One in particular is this steering shaft. It started out as a pretty basic steering shaft, but we kind of fancied it up with a few specific parts, so we just want to show you guys how you could also do that at home.
And sticking with everything on the inside, we're gonna be going over some wiring, and we're gonna build out a custom dash because we're gonna wanna mount our massive screen so we can watch all the vital signs of the EFI and our engine. Plus, we're gonna show you guys about this really cool little thing. It's called a PDM, but we're gonna get to all that wiring fun in just a little bit.
Steering is an important part of any build, whether you're doing a full-on race car or a street cruiser, and there are some options out there for you depending on what you're doing. You can get a full-blown tilt steering column with turn signal switches, you can get a straight street rod column, or in our case, you can go as simple as a steering shaft. But personally, I do like the higher end racing columns that have a separate tube on the outside that mounts rigid to the inside of the car. That way when you turn the wheel, you don't actually see the steering shaft spin, but those tend to run somewhere in the $800 to $1,000 range versus just a simple steering shaft. You're probably in it for about 250 bucks. But how can we do something that's a little bit higher end and give the interior a little bit more polished look for less money? Well, I did come up with a solution, and we've had this in our car already, but I wanted to show you guys how you could do something similar at home. So what we have here is just a basic steering column that we have from Speedway Motors. It comes with the shaft. It is a collapsible steering column, which is a good thing because in a race car application, if you were ever to get into an accident, you want to keep the driver safe. And it does come with the quick release for the steering wheel. And so to turn this into a nice column, we just need a little bit of extra money in terms of tubing, a couple bearings, and some shaft collars. So the basic process to this, with this specific steering shaft, the tubing used is 1.5 inch OD by 1.370 ID or 065 wall. You can use steel or aluminum tubing, just depending on what you're feeling. And for the bearings, it's an 1812 needle roller bearing, and those bearings have an OD of 1.375. So with this tube unmodified, that's a 5 thousandths press fit, which is way too much. So if you have access to a lathe, you'll need to turn this ID just a little bit. Or if you are using an aluminum tube, you can use one of those 3-jaw spring-loaded hones to turn it. And you want about a 1,000th press fit. You definitely don't want these falling out. You do need them to stay put. So also, if you do want to prep the tube and give it a nice brush finish like ours, and ours is a little beat up because we've had it in and out of the car several times, you can use a red scuffing pad, and with very little work, I mean very little, we probably did ours in less than 3 minutes. Just take it, just work it by hand just a little bit, and even just on this one spot, it's already cleaned up quite a bit, so you spend a little bit of time on it, it's gonna look really, really nice. So with your tube cleaned up and your bearings pressed in, you can start to assemble, starting with a shaft collar at the top of the steering column. And just go ahead and get our outside tube slid over. And then we'll put our other shaft collar on. You do want to leave a little bit of a gap here. You don't want it super tight. You want this to have some movement in the axial direction. That way you don't get any bind from the steering shaft rotating inside of the tube. And that's pretty much it. You took a pretty basic steering shaft, turned it into something really nice, and with your quick release and wheel of your choice, you have something that looks a lot better on the inside of your car. But there's a little bit more involved just to get it mounted, and in our case, because we do have a race car, when we have a roll cage, we can use some of these cool tube mounts. These are made by Sweet Manufacturing. We also got these from Speedway Motors. So this fits a 1.75 inch tube, which is what our roll cage is made of. And then this tube clamp fits around our aluminum tube to hold it rigidly in the car. And it just gives it such a good look, and depending on driver height, maybe how far the seat is from the Firewall, you can get these in different sizes. You can get the shaft in a different length to fit any application. But regardless, this looks a lot better in our car, and it's gonna perform just like the expensive ones.
Coming up, we install the dash panel for our Camaro so we can install our gauges. Jimmy has the steering installed back into the Camaro, so now I can start working on the dash. The idea behind this is pretty basic. I'm just gonna take a piece of aluminum and bend a 90 on it. We're gonna have that land on top of the roll cage here, and then land in this little recess of the stock dash, or what's left of the stock dash. It's gonna be a little tricky. There's a little bit of contour to the dash up top here, and it kind of arcs in this direction, so we'll have to do some basic trimming. But from here, we'll take some measurements. I'll hop out of the Camaro. We'll go transfer that onto a piece of aluminum. So we have our line laid out, so we're just gonna cut it out with the power shear. Now, if you guys don't have one of these, you can use a cut-off wheel, or if you have a plasma torch, you can do it that way as well. But we're just gonna use a shear because it's quick and it's easy. All right, so now that we have our piece cut out, we have to add our bend right here in the middle. So we'll head next door, whip this thing into shape. Yeah, you got her pretty much right on the line.
Yeah.
This ain't too critical. And 90. Oh, Betsy. You're really gonna have to help me pull. Man, that's thick. Let it relax once. All right, a little more. That's probably close. Let's check it once. Yeah.
Go, man.
That should work. All right, so now we can't fit this into the inside of the car just because of all the roll cage tubing that Jimmy has in here. So the easiest solution to get this thing to fit is we're just gonna take out the windshield. All right, do a little test fit here. Slide this in. Looks like we're a little wide. That's not a big deal. I think an easy solution to that is we'll just come in and kind of nip the corners off. And then we'll just do another test fit quick. Go grab the shears. All right, so we'll do a little test fit here again. See how close we are. That actually fits. Really good, it lands on the center of the roll cage here. But now we have the challenge of somehow trying to find a way to get this line of the edge onto our dash here. Now, really can't do it from the bottom by just solely tracing because it's got too many variations in here where the original dash hooked to, so that's almost impossible. But I did come up with an idea here on how to transfer a line a little bit further out so we can see it. So if we take a Sharpie and a compass, I've got this set at about 2 inches. What I can do from here is trace this line with the Sharpie mark right on the dash. When I put the dash in here, I'll be able to see that full Sharpie mark. And from there, all I gotta do is flip the compass around, eyeball, follow the best I can that mark. It'll transfer it back onto the top of our aluminum dash. Then I just have to trim it out, and it should fit. Trick here is to keep the compass at a 90-degree, because if we let it go one way or the other, the measurement will change, or the line will change too, so. Okay, so now that we have our mark on this part of the dash, what I'm gonna do is stack up a couple layers of tape right on the edge. That way, when we set the compass side or the pointy side of the compass down to trace this line, the edge has something to follow. So I can stack up 2, 3, 4 layers of tape here, and then we'll put the dash in and transfer it over. There's one.
Do this, you get really good at stacking tape and following a very specific line.
Okay, so we have our tape down. I did trim the edges here because this line was covering up our new tape line. So we got Jimmy here to help hold this square in the middle on the roll cage tube that's down here, because that's where we're gonna want it to land anyways. Then we'll take our compass. Again, we're gonna use the pointy edge, run it up against the tape. We should be good to go.
Harder than it looks.
Right. see how this thing fits. Get it all lined up here. Yeah, actually fits pretty good. So from here, it's pretty simple. All we're gonna do is drill a couple holes through the aluminum into the dash itself. We'll have to cut out a couple tabs. We'll weld those onto the roll cage tube, and we'll just grab some nuts and some bolts, bolt it all down.
Now that our dash is complete, we need a way to install our new digital gauge cluster.
All right, so we have the dash installed in the Camaro, and the way that we pulled that off is we had Jimmy cut out the same tabs that he used to mount the rear firewall. We took that idea and just pretty much copied it. We mounted those tabs to the top of this roll cage tubing, and then I just put a couple riv nuts in it, and we just tightened it all down. I did have to do a relief cut here for the steering column, and then on the top, since the dash actually has curvature this way, I did a little relief cut underneath this side and that side of the dash and kind of just bent them down so it matched. So we're gonna call that a win just because it looks really good. So from here, we're gonna move on and mount the Pro Dash that we got from Holly. Now, this screen is pretty big. It comes in at 12.5 inches, and it's got some pretty good weight to it too. So the solution to mounting this is on the back of this aluminum casing. They actually have a couple holes that are drilled in here so you guys can build a bracket, or you can use it to build a piece of steel to mount it to. Instead of getting out our ruler or our tape measure, they also send you this handy dandy little paper template. So what we're gonna do is cut this out. We're gonna transfer it over to a piece of sheet steel. This is 16 gauge steel, and that should be plenty strong for us to mount it to, but more importantly, it's gonna give us something to weld to. Like arts and crafts when you're a little kid, right? Stay on the line. All right, now we'll use just some painter's tape or Scotch tape here. We're gonna hold this into position, and then we'll go grab a punch and a hammer, and then we'll punch out the center of all of these holes I gotta drill. All right, go grab a bunch of drill bits, a couple hole saws. Okay, so we have the holes that we need drilled out. Now we'll just go ahead and cut this out with the cutoff wheel. All right, let's get this thing on here, get it bolted down. All right, so we have our plate made now. We got Jimmy in the driver's seat. We're gonna try to come up with a good spot to put this. This is kind of where we're thinking, is somewhere here. Now, can you see up and over the top of the dash? We're not blocking anything.
Yeah, it's just kind of a compromise of not having to turn your head so far.
Right.
If we put it over here, and I mean, naturally in any car you drive, you have the steering wheel that somewhat blocks your view of the dash, so having to move your head around, it's not that big of a deal. So I think this is probably
good. You don't think that's gonna get in the way, like if you gotta bail out of the car real quick?
No.
Okay,
no,
not that your knee's gonna hit it? Okay. Let's take a couple measurements and we'll build a bracket that fits in the roll cage tubing here. That's roughly 8. And we're gonna go 13-ish. Okay, now grab that. We'll cut out another bracket. Okay, so we have the basic shape for the bracket laid out. I'm gonna add a couple more marks here. Plan is to add a tab. All All right, so now what we're gonna do is bend this tab over. We're gonna bend it up at a 90. This is 1/8 inch steel, so it's gonna be a little bit of a challenge. But I think what we're gonna do here is score a line on the back with the cutoff wheel. That'll let it bend a little bit easier. That way we can just set it in the vise here, give it a little push. And once we got it where we want it, we'll come back and then we can always just tack that edge back up to put the strength right back in it. So use the vise to hold it, score a line quick. So we'll set the vise a little bit deeper so it's close to that line. And that should just bend. Heck yeah, just like that. As long as it doesn't break, but we can always weld it if we have to. Nice and slow. Sneak up on the 90. There. Voila, let's go do a test fit.
All right, that should go like that. That looks pretty good, but let's go give it some style.
All right, so the dash is installed, and it's in a pretty good position. Now, one thing to note, steering wheel does kind of cover up our vision just a little bit, but it's like any daily driving car. This way, we don't have to take our eyes off of our line of sight or going down the track too far to look at the vital signs of the engine. So we're gonna call that a win for now. We'll check one more thing off the list. Coming up, fuses and relays are a thing of the past. We'll show you a new way to distribute power to your project. So we have our dash installed in our Camaro, and that got me thinking about wiring. So let's go over the way you might wire a traditional circuit in a car or a truck. You're gonna have 3 or 4 major components here. You're gonna have a battery, got a fuse box, got a switch. In our case, we have a relay because we're gonna have a high load like a headlight. There's nothing wrong with all of this. It's just the fact that it takes 3 or 4 different steps to get to the final result, which is turning on your headlight. And that's not the way we're gonna be wiring up our Camaro. We're gonna be doing it a little bit differently. We're actually gonna be using something called a PDM. This little black box right here is a PDM, or a power distribution module. It's also known as a solid state relay. We got ours from Switch Pros, and they sent us basically everything we need to get started wiring in our car. Now, they've got a bunch of different circuits here, so you have a handful of wires that can run up to a 15 amp circuit, and then they give you a couple wires here that can also run stuff like 30 and 35 amp circuit. Now, this whole system gets away from any types of relays, and it gets you away from fuses, which kind of simplifies everything. Now, the way you control all of this is with this little keypad here. This keypad is Bluetooth operated, or you can use it by pushing the buttons, but to set it up, use the Bluetooth. Then we can set up the pad or the buttons to do specific things. So I've got a little demonstration here. Let's go over kind of how all this all works. So we're gonna turn on our key. In our case, it's just a little toggle switch, and that's gonna fire up or power up our PDM. Now, over here on the keypad, we've got certain buttons to do certain things. So if you want to turn something just straight on and off, like a fan, you can do that. If you want something to be momentary, so push and hold the button, like the starter. Or they also have special functions, so if you guys want to have lights that strobe, you can do that. Or you can just turn lights on so they blink, so if you guys want to run blinkers. Now, you're thinking to yourself, well, there's no fuses, so what happens if I have an issue with the circuit? Well, we're gonna do that scenario as well. So in the back, we have a little light that turns on, and let's say this circuit or the wire kind of rubs through, touches your frame, and it grounds out your system. Well, the PDM's gonna save itself, and it's gonna tell you there's an issue with that circuit. So if we go to push the button again, got a little light on top of it that blinks, telling you there's an issue with the circuit, you need to repair it. So once we come back, do our repair, we can turn that circuit right back on with no harm done to the PDM. Now, this may look very complicated, but it's actually quite simple to set up. We're not quite ready to wire up the Camaro quite yet, but when it comes to that point, this is the system we're gonna be using. Well, Jimmy, what do you think about everything inside so far?
I love it. I just love the look of all the fabricated pieces, a lot of straight lines. It looks super neat. and also where the dash is. It's not too far away. It's just a quick glance and we can see everything we need to know.
Yeah, we checked a lot of things off the list, but we still have a lot to do. We've got the oil system to take care of, the cooling and the fuel system as well.
But we're not going to get to that today, so until next time, thanks for tuning in.
Today on Carcass, we stretch out our polycarbonate rear glass on our road course Camaro to get an aerodynamic fit.
Then install a major safety feature to give us a few more extra seconds in case of a fire. Plus, fabricate a bracket to help us locate our dry sump oil can. Hey everybody, welcome to Carcass. Well, Jimmy and I want to check a bunch of things off the list today because we are in the final stretch of getting this car running as a complete race car for the very first time.
And all that stuff includes plumbing, all the liquid systems for the engine, fuel, coolant, of course, and the oiling system. And we also want to show you guys how you can set up a bell housing on your engine for a manual transmission, something that I think often gets overlooked. And then we're also going to be getting our rear windshield installed. There are a couple ways we could go about doing this. The first being installing the original glass, which would be the easiest. However, we do see this as another opportunity to save a little bit of weight. So we're gonna make it out of polycarbonate just as we did the front windshield. But we can't just lay the polycarbonate in this original channel because it'll sit well below the surface of the body and it's not gonna look that good. So what we're gonna do is build a new shelf in this channel for the polycarbonate to sit on top of. That way it'll look really good and it'll be flush with the body and give it a good aerodynamic surface. And something that's gonna help us out with this process are these little pins in this channel. These pins were originally used to hold in the chrome trim pieces for the rear glass, and this will give us kind of a guide of where to put our new shelf. And by the time we take into account the thickness of the polycarbonate, it should sit just about flush with the body. So to get started here, I'm gonna need some steel and a shrinker stretcher. First thing I did was cut our big piece of metal into a 1-inch strip, and I'm gonna build this in multiple smaller pieces. I think it'll make it a little bit easier. But basically what we're trying to do is to match the contour of the perimeter of the window opening. And to do that, we're gonna be using a shrinker stretcher. Basically what this does is when you put your piece of metal in it and step on the pedal, there's two little jaws that either spread the metal apart or bring it together. And that way you can make a compound curve like this to match the outside perimeter of our window. So basically what I'm looking for here as I'm test fitting this is just where the gap starts to form between the strip that I cut and the outside perimeter of this window opening. So wherever that gap starts to open up, that's where I'm going to start placing the next bend. I'm just trying to make sure the gap, if there is one, between the outer windshield kind of frame here is small enough that I can weld it without much trouble. That's a good fit right there. Also just trying to make sure that I hit these other pieces and line them up right so this can look more like it's one piece, but just a little bit of time and patience. Now that I have the new shelf all tacked into place, I did go ahead and trim out our new piece of polycarbonate. And the way that I did this is I used the stock rear glass as kind of a template, and then it was a very iterative process from there. So it was a lot of back and forth to the car, trimming little areas here and there to get the profile perfect. And so what I'm gonna do now is actually drill all the mounting holes in this polycarbonate all at once. So that way when we start to put the rib nuts in the new shelf, we can go ahead and mount it from the center out and really pull this thing into shape. All right, so what I've done here is I've taken a square and I've set it to the offset that I wanted. And that way it makes it easy to just trace an entire line around this. This is kind of a complex profile. It's not a perfectly straight line. So this will help make all the marks we need to drill our holes. Now I'm just marking the holes, going 5 inches apart on these It's about 25 inches from the edge to the center, so it'll give us 4 in between. Ready to put the first rivet nut in here, and so the way that we're gonna do this is once I get these 2 rivet nuts in, put the piece of polycarbonate back on here, and then we'll just start going each series of holes one by one until we make our way all the way to the outside. The reason for that is if you just try to bend it by hand and mark the holes on the very outside, it just doesn't work that well, because especially with a piece of polycarbonate like this that has pretty extreme curvature, it's too difficult to do it by hand to get an accurate placing of the holes. On a flat piece of polycarbonate, you can, just once you get the centers in, just mark every hole and drill them. But in this case, we're just gonna have to be a little bit patient and take it one by one. That's pretty much it. We've got all the hardware in it, and now there will be some minor tweaking just to get this thing fitting perfect. But as you can see, we're nice and flush at the top here. We're gonna go ahead and chamfer the bottom edge just so it sits down in the channel and clears all those tack welds. Then we'll get some new hardware in it, paint a nice black border on the inside, and then we'll call it done.
Fire and race cars don't mix. Coming up, we extinguish that threat and show you guys how you can buy yourself a little more time getting out of your race car a little safer. Fire is bad. Fire in your race car is even worse, especially if you're trying to get out of your race car safely. Now, we don't want you fumbling around trying to grab your fire extinguisher, disconnecting it from the straps so you can get out of the car. Now, we're not going to be using a fire extinguisher like this on our Camaro. What we are going to be using is a self-contained fire suppression system that's designed for race cars and race trucks. This is a Zero 2020 system from Lifeline, and we got this one from Summit Racing. Now, this isn't necessarily designed to put out a fire. What it's designed to do is give you more time to exit the car safely without catching yourself on fire. The way that this system kind of all works is you have a bottle or a fire extinguisher, you have some hard lines, then you also have some nozzles and some pull cords that need to be in a very specific area, and Jimmy's gonna help me set all of that up.
Like Jeremy said, these need to be mounted in the right locations. And number one is, as a driver, we need to have a pull handle accessible while we're still strapped in the seat, just in the event that our car catches fire. On the other side of things, worst case scenario, if we get into an accident and we're knocked out, the fire safety crew has to have another handle accessible from the outside so they can go ahead and pull it, and it gives them time to get us out of the vehicle safely. So while I'm getting these mounted, Jeremy's gonna be mounting up the bottle.
So for all of this, basically thinking, since we have this plate over here, we can mount this kind of towards the back, and the pull cords, they come in from kind of the bottom side of the extinguisher and engage in here, so that way the cords can come up this direction, and then the nozzle connection is on this side, and we come over here and grab kind of the roll cage tubing and start plumbing in and going wherever we need to go.
Yeah, because we can loop the cables up together, and then I think I'll have our pull cord right under the digital dash here.
Right.
And then obviously 2 nozzles down here, kind of pointing a little bit down, like at our legs, feet kind of. And then the exterior one for the fire crew, we'll put it up here on the roll cage, make a plate here, and we'll also put the kill switch, another kill switch out here too.
Yeah,
so
that's a good idea.
I think that'll work out.
Well, with this all set up over here, this is going to be pretty basic. I just have to drill a couple holes, so I'll go ahead and drill the holes for this. We'll get this mounted and we'll start kind of plumbing and stuff in.
Yeah.
Good. All right, we'll just set this right there.
Now it's time to get our mounts for our cable pulls in here. This is just a simple flat piece with a dimple die. This will go in the upper A-pillar area for the fire crew to get their fire pole. And this piece right here, just broke it 3 times, blended the welds on the corners. This one will go up under the digital dash so we can reach it while we're sitting in the seat. Luckily, they send you with quite a bit here, so regardless of your application, you'll have more than enough length. We can just trim this to fit. One thing to note here too, with this bracket in particular, there is a pilot hole drilled here. We don't know the diameter of what our kill switch will be yet, so once we get there, we can just drill it out and get that all mounted up as well. So what I'm gonna do here is just kind of get these roughed in a little bit, trying to figure out what route we want to take to get to the fire extinguisher bottle. I'm thinking probably go across the dash bar all the way over to the passenger side, then drop it down on the floor just to keep everything out of the way. And then at that point, we can kind of trim everything up and finalize these cables.
All right, now that Jimmy has the pull cords installed on the interior, we're gonna move out here to the engine bay and start installing our nozzles. Now the instructions call for these to point towards an ignition source, so something like the fuel rails, and then the way that these spray out, it's gonna fall on top of our headers, which is just gonna be a big help as well. The place we're gonna put them is right here on the corner of our roll cage tubing. We took a piece of manila folder here, traced out a design that we liked, transferred that over to a piece of metal here, and then we'll just tack this in the corner, and then we'll put our nozzles inside that little hole I have drilled out, and we'll call that installed. Okay, so once you have your nozzles installed, you can grab the supplied tubing, and this is kind of a push lock style, so it just pushes into the back of the nozzle and locks it in place. The tubing itself is an aluminum tubing kind of wrapped in plastic, and it's quite pliable. You can bend it and it retains its shape very well. So we'll be able to kind of graft it around and put it where we need to put it. So we've got 2 more to put into the engine bay here for a total of 3 in the engine bay. We've got 2 nozzles that need to go into the car for a grand total of 5. And once all that's installed, we'll check a major thing off the safety list. Coming up, we install a huge oil tank for our dry sump oil system. So we have our fire suppression system mounted in the passenger compartment, and sticking with that theme, we're gonna mount a couple more things onto the car to get it further along. Now the engine that Engine Power built us has a dry sump oil system, so there is a giant oil tank that we have to mount. And the best spot we could find for this is back here in between the 2 firewalls that Jimmy and I have already built. This just keeps the tank itself safe, and it keeps us safe just in case we have an oil leak and we don't want to get hot oil all over Jimmy and myself. So this did come with a mount, or at least a mount that Engine Power did use on the dyno. We can't use this mount, but the basic idea of it is what I'm going to copy. So what we're gonna do is kind of get this into place here. I'll take a couple of measurements. We'll copy that mount onto some steel, and we'll get this thing mounted up. All right, we'll do about 1 3/4 inches. Okay, so now that we have the little standoff made, we're gonna end up cutting this piece of the bracket out. I'm gonna do it on this piece of 1/8 plate steel. Measurements we're gonna use for this are 3 inches wide by about 8 inches long. Ow, that landed on my foot. Okay, to get this into shape, or that half moon shape that we need, we're gonna use something called a slip roller. The way that this works is we've got 2 adjustments on the back here, and it kind of decreases the distance between the rollers. What that does is put pressure on the rollers themselves, and then the more you go back and forth, it will start taking shape here, kind of like that half moon that we're going for. With this being 1/8 inch plate steel, this is gonna take quite a bit of rolling just because it's so thick and so heavy, but we'll sneak up on it and we'll get there. So. Okay, so we have our piece made here on the slip roller, and it fits this tank really well. So now what we'll do is we'll take the stand off, we'll get that up here on the roll cage tubing, and we'll put our piece that we just made on the roller in here, and then the challenge will be getting this kind of all set in here and make sure everything's level. Then we'll kind of tack everything together. All right, now that we have the bracket all welded up, I did choose to just do it over here on the table because it was just gonna be a bear to kind of weld on the bottom side of it. Just makes life a lot easier. We'll go ahead and place it all over here on our oil tank, and then we will get this just kind of loosely bolted into place, and then we'll go back over to the car and tack it back in. Now, like I said earlier, we're gonna be running a dry sump oil system in our Camaro, and the way that that differs from a traditional oiling system is that in a traditional system, you have an oil pan which houses all of your oil, you have an oil pump, and you have a pickup tube. Now that works fine in your everyday ordinary driving vehicles, but for us in our Camaro, when we get out onto the racetrack, we can encounter some G-forces that could actually slosh that oil to one side of the oil pan, uncovering our pickup tube, and that can starve our engine of oil. Now that slosh can also get up into your rotating assembly, which is called windage, and that windage could actually rob you of horsepower. And the way you get away from that windage is to remove all the extra oil from the oil pan and put it into an external oil tank like we mounted on our Camaro. And when you get away from all that extra oil in the pan, you can actually go to a smaller oil pan, but that poses a little bit of an issue because then you can't run an internal oil pump on your engine. So a solution to that is to run an external oil pump for your dry sump system. The reason why it's called a dry sump is that the smaller oil pan is tentatively dry, and the external pump scavenges or removes the oil from the oil pan and gets it to and from the remote tank. The pump we're using is a Moroso 5-stage oil pump that uses 4 stages to scavenge oil from the oil pan and 1 stage to deliver oil to the storage tank and send it back through the engine. And by running a system like this, we get 3 major advantages. 1, we don't risk starving the engine of any oil. 2, by running a smaller oil pan, it allowed us to set the engine lower in the car, and that will increase our handling. And 3, by getting rid of that windage, we were able to pick up a little more horsepower.
We mock up the race clutch setup to show you how to measure for a release bearing. Race cars are pretty cool because they use a lot of parts that we don't really get to see outside of the very specific world of racing. One example of that on our car is the clutch system. This is a quartermaster 3-disc clutch, and it has quite a few differences than even the highest performance street clutches that you might see out there, with the biggest differences being the overall diameter and the materials used. As you can see, this clutch is very small at only 7¼ inches, and the disc material is a sintered metallic type. Whereas on a street clutch, you're gonna be more in the 10 to 11 inch range, and the disc is either gonna be organic or a combination of organic and metallic materials. Small clutches are great for race cars because it allows the engine to spin up quite a bit faster, and if your tires can hold it, that means you can accelerate faster. The downside to a clutch like this on the street is that there's not a whole lot of inertia to keep the engine running when you go to release the clutch and take off. That's why street clutches tend to have really big, heavy flywheels, so you can get that gradual transition and give yourself a smooth takeoff. The other downside to a metallic clutch is that they don't deal with heat too well. When you start to grind them and they generate a lot of heat, they can wear out very quickly, whereas an organic compound is made to take the abuse from the heat, so if you're in stop and go traffic, it can handle it without much problem.
Now I'm just trying to mock this up here so we can get some measurements for our release bearing. So I'll go ahead and throw this up here. We'll start taking some measurements. Not too worried about getting everything torqued down right now. We're just trying to get this mocked up so we can take a couple measurements. All right, so what I'm gonna try to measure here is from the fingers of the pressure plate to the back of the bell housing, which is 3 1/4, but I have to subtract the distance from the back of the bell housing to the mounting pad of the release bearing. So 3 1/4, that's 1.120. So that's gonna be 2.13 inches. And then we're also shooting for 200 thousandths gap to allow for clutch wear. So that'll give us 1.93 inches height in our release bearing. So we'll go ahead and get that ordered, and then we can do final assembly. But in the meantime, we still have a lot of work to do, so we'll catch you guys next time. Today on Carcass, we'll add some Aero to our 72 Camaro, fabricating some brackets to mount our huge wing.
Then we'll shore up our suspension by adding some new coilovers and shocks. Plus, install our brake and clutch hydraulics and show you some tips on how to make and run your own brake lines. Hey everybody, welcome to Carcass. We've got our 72 road course Camaro up on blocks today. We're getting really excited to get this thing out of here because warm weather is coming and the racetrack is definitely calling our name. Now, a couple shows back, we did take some measurements for the suspension and we've got some bits and pieces in, so that's what we're gonna tackle today. Up front, we're gonna be installing a set of coilovers, and in the rear, we're gonna be working on the shocks. Now, speaking of the rear, Jimmy's got something going on back there. I don't want to be the one to spoil all of that fun, so I'll let him tell you all about it.
And we are talking about Aero. On a car like this, we wanted something that was proven to work. And so what we didn't do was go buy some random wing, slap it on the trunk lid like that Honda Civic you see driving around your hometown. So we turned to 9 Lives Racing and they sent us one of their big wang kits. And these things are really awesome because it has a CFD designed wing profile and the wing element itself is an aluminum extrusion, which is very lightweight and it also helps keep the cost down. They did send us their end plates and we do have wing mounts that we'll have to weld on at some point too. Another big part of this is where do we actually locate the wing? Luckily for us, our Camaro has a pretty gradual roof line, so the air is not really gonna have a tendency to separate and get turbulent, and we're gonna have a really good chance at getting clean air over the wing. So for us, we're not gonna go too low right up against the trunk lid, but anywhere around the roof line or maybe just a touch below the roof line, I think we're gonna get some really clean, good air. Now front to back, you also have to be careful here. We don't want it too far back because downforce on the wing, it kind of acts like a seesaw around the rear tire. The more force you put here and the farther back that you go, it's going to start lifting up on the front end, which you don't want. We will have a splitter to kind of balance out the downforce on either end, but you don't want to go too extreme. And we also don't want it too far forward that it just looks weird. So I think right at the roof line and right at the back edge of the car, I think that's going to be a really good balance. So now I have to design some pylons to attach to the car and then attach the wing to the pylon. So I'm gonna get the trunk lid removed and then I'm gonna start cutting up some cardboard and make a template. The design of the pylons is gonna be pretty simple. We're just gonna go from the trunk floor to the bottom of the wing once we get the mounts on. The trunk floor is nice and flat, so it'll give us a nice base to build off from versus trying to mount the wing to somewhere on top of the quarter panel here might be a little bit challenging. So we're gonna weld a nice spreader plate to the trunk floor just to make sure the area is nice and strong. And as far as the pylons go themselves, since they will be protruding through the deck lid, we'll have to cut some nice long slots to make sure the deck lid can still hinge if we need to get some access. So I'm just gonna get basic measurement here for height, and then we'll try to build out cardboard template. Now 30 inches. So I've got the wing mount from 9 Lives Racing, and I know that going down from the wing, the pylon's gonna have to kind of come forward a little bit towards the front of the car. So I'm just gonna kind of draw a random shape because it doesn't really matter what the shape of it is. We're just trying to get some basic lines down here so I can start cutting something out and just kind of trim it to fit. So just gonna kind of start something kind of in that range. We might try to make it a little skinny up here, give it a little bit of style, but I'll cut it big at first and then we can kind of whittle away at it. All right, so here's our finished template. There are some details that I'll have to add once I get this thing into CAD. Basically, I'll have to match what this wing bracket, as far as the holes go, just so we can maintain adjustability. But yeah, nothing too crazy, but we'll get this set up in CAD and then we can send it off and get it made. CAD is really useful for things like this just because if you want to send off something to a laser cutter, maybe you don't have the capability or the tools to make it yourself, it's a great solution to make some custom parts. And with a lot of people, there's a couple of big shops out there across the US that you send them your file, they send the part back. And with a few of them coming out now, it tends to keep the price a little bit lower just so guys can stay competitive. So it's a nice thing when you can get parts made. CAD is free for the most part, depending on the program. You can get really high quality parts for fairly inexpensive cost. We've got everything in CAD finished up, so now all I have to do is send off our file to our laser cutter. When we get it back, then we can finally install the wing.
Coming up, we install our new coilover setup and adjust our rear end to get more traction on the track. With Jimmy pretty much wrapped up in the back, we're gonna move up to the front here and start working on the suspension. Now to get down to where I need to be, gotta jack the car up here and get the wheel and tire out of the way. So what I'm doing now is taking out the setup rod that we have in our suspension. This was a rod we used to adjust the ride height of the car, kind of up and down. Then once we landed on a spot that we like, we sent the measurements off to the guys over at UMI Performance, and then they built us a shock and coilover combo. So that we have those back. We can go ahead and put that coilover setup in here, but I do have a couple brackets that I have to get off down here on the bottom, just to make enough room to slide the coilover in. So the coilovers that we're gonna be running, these are Viking Crusaders, and again, we got these from the guys at UMI Performance. And the way that a coilover works is you have the shock body here, and then you just put a big coil spring over the top of it. Now what makes this different than a regular shock is the body of a coilover is threaded, so you have these big threaded keepers or nuts down here on the bottom, and that way you can adjust your ride height. So what we're gonna do is install these into the suspension that we have already installed from UMI. They should bolt right in, and then at the very end here, what we're gonna do is get the car back on the ground. Once we get all the weight in it, from there we'll reset our ride height. And we'll put these lower brackets on that hold the coilover into place. And then we'll put the spacers in that came with the kit. We'll put the coilover in place. Okay, so one thing to show you guys, you've got these two little knobs here. One's got a C on it, one has an R on it. That stands for compression and rebound. And with these two knobs, you can adjust the way that your suspension handles, and that can win you races. Now in the back, it's a little bit different because we're running a leaf spring, so we can just use a standard shock. Now we are going to address something about the ride height, and that's underneath the car, so let me show you what we're talking about. Now the way that we set the ride height before on the Camaro is with this lift block between the leaf spring and the axle. We think the Camaro sits a little too low in the rear, so the way that we're going to change that is with a shorter lift block. Now this is a little bit backwards in the fact that the axle is sitting on top of the leaf spring, so we do have to run a shorter lift block in order to actually raise the car. It's pretty simple to do. We're just going to loosen up these two U-bolts, we'll switch these blocks out, and then we'll install the shock. Now we'll just probably pick the axle up and swap the block out. All right, I'm just gonna snug these up for now. When I go to do the driver's side of the car, we'll need these to be a little loose. That way the axle can kind of flex as we pick that side up to put the block in it. But snug these up, and then we can go ahead and get our shock up and in here. Okay, so again, the shocks we are running are Viking series shocks. The fronts were Crusaders series, and this is a Berserker series. Pretty much the same, just different in the fact that this is a shock and not a coilover like the front was. We're gonna get these installed in here and then keep them loose. We won't tighten anything down. We still gotta do the other side with the lift block and then bolt the other shock in. Then we'll come back when it's all done, tighten everything down.
We fabricate a mount for our clutch and brake reservoir so we can finish installing the master cylinders for our pedal assembly. Now it's really time to start looking at our braking system. We've had the pedal box mocked up in here for quite a while. Now we're going to start putting all the parts and pieces in and make sure everything fits like we think it should. That includes getting the master cylinders installed for the front and rear brake circuits along with the clutch. Then we're also going to mount this reservoir, which I can already see a problem with one of the brackets for one of our fire nozzles. It's right in the way of where I want to put this, but that's exactly why you mock a lot of this stuff up. That way you just have to cut a couple tacks and you can move things around as needed to make sure everything works. So I'm going to go ahead and get started on the bracket. We'll get this installed first. All right, so this bracket is going to be pretty simple. We have 1 3/4 inch flat stock. It's 1/8 inch thick, and the bolts here on this reservoir are 2 3/4 inches apart. So we're going to go ahead and cut 4 inches for the bracket. We'll cut this out and then mark our holes and get them drilled.
went ahead and cut off our little bracket for the fire nozzle. So I'm just gonna get our reservoir bracket tacked on, and then we'll start getting the lines in. To finish out the mock-up of our brake system on the inside, we're gonna be running some dash 4 lines from the reservoir, and we're gonna kind of run these 90-degree fitting out of here, run these down the roll cage underneath the heel plate, and then we'll be running these dash 3 lines that will go 90 out of the master cylinders, and then they will all go through their own bulkhead fitting at the Firewall, and that'll get us to the outside. And then we'll throw the heel plate on it, just make sure everything fits like we think it should, and then we can start working on the rest of the brake lines on the outside of the car.
We'll show you some helpful tips and tricks when making your own brake line. Back to the handy dandy trusty. So now that we have the master cylinders installed in the Camaro, we're going to continue on with the brake system. To go along with our EBC rotors and our calipers, we also have their high-performance brake line kit. Now this comes as a set of 4. It also comes with the adapters so we can hook the lines up to the back of the calipers. So we're going to go ahead, get these installed, and then we're going to come back and talk about some hard lines and how we're going to flare them. Now these brake lines are stainless steel, they're 100% pressure tested and guaranteed for life, and they're gonna give us a firmer, more responsive feel out of our brake system. Now these aren't necessarily for our 72 Camaro, they're actually for a C5 Corvette because that's the calipers that we're running, and they also have a bunch for other applications, and they even have some for motorcycles. The next step here is to figure out how we're gonna route this thing and where we like it, and then we'll go ahead and weld on the mount for the other side of the hose here. Tighten this up, then we'll check the steering. Last thing to do here is to turn our steering from lock to lock to make sure we don't have any binding or any pinching in the hose. That looks good that way. We'll go this way. Looks good that way as well. All right, from here, we'll move on to the hard brake lines. So the lines that we're going to be running are 3/16 in diameter, and we did get a spool of line because we do want to run these lines in one continuous length. So we also have a straightener here that we're going to use to straighten these lines out. Now as far as the flares go, the original flares for the car are going to be a 45-degree inverted flare, but since we are running the EBC hoses here, these call for a bubble flare solely because they're for a C5 Corvette. So we do have this special little tool here that's going to create those flares for us. But before I really dive into doing any of the flaring, I need to get this T in place so we can take a measurement for the line. Okay, so we think we'll set the T right here on the frame rail. That way this side can go to the master cylinder, that can go to the passenger side. This side will come over here to the driver's side. So we'll take a quick measurement, get a ballpark here. Let's go 6 or 6.5 inches. We'll go bend up a line. So the line that we have to make is a little tricky in the fact that one side has to be a bubble flare, so it's kind of like this one here where it's got a little bubble or a dome to it. But on the other side, we have to do that inverted flare, kind of like this one is kind of concave, so it goes down like a V. So we'll go ahead and pull some line out, get it straight. So after we marked it at about 6.5, we'll grab our tube cutter here, and then we'll just cut the end off. So with this, you have to go a couple turns at a time, and then you tighten it, a couple more turns, and tighten it until it comes off. Just like that. All right, now we'll put our flare tool in the vise here, and we'll get it set up to do our first flare. So on a flare tool like this, the first thing we have to do is set the depth of the line in the keeper there. We'll tighten that down. Then we come over to the 3/16 option and just give her a good pull. And that is all we have to do to flare. Okay, now the most important step to doing all of this is don't forget to put the line nuts on, because then you have to redo it again. So on the other side, we're gonna do the 45 inverted flare. And I've been working with a flare tool like this for 8-10 years, and I have never had a flare leak. But we'll knock on wood, because it'll probably happen this time, but hopefully not. All right, we'll take it out. And that is perfect flare. Okay, so over here we do have to put a little bend in this. So we have our little line bending pliers. So we'll get a basic idea of where that bend needs to go. Give her a little bend, somewhere around a 90, I think. See how we did? Okay, check to see how we did here. I think we'll be a little off. We may have to do a little bend in here yet. Check to see, yeah, we'll just kind of use it like that. And that should work right about there. Now we'll go on to the passenger side. Okay, for the passenger side, it's gonna be a little bit tricky because we have to get from here all the way over to the T. So what I'm gonna do is use some string to help kind of lay the line out. That will kind of give us the path we're going, plus it's gonna give me a length. Then I can take that over and we can cut it off the big spool over there. Right about there. Okay, so a big trick to do here when you're bending a very long piece, in this case, this one is 70 inches long. Take a piece of welding wire or mechanics wire that you have, and you can start mimicking the bends you want to put in it. This way, when you lay these bends out, you don't have all that extra line hanging out in la-la land. So if I can get a couple bends in this piece, I can just transfer this over to our long piece. And it should work out. Well, that buttons up probably one of the hardest lines that we're gonna bend on the car. So from here, what I have to do is go from the T into the master cylinders in the passenger compartment, and then work on plumbing the whole back side of the car as well. We're not gonna get to that today, so that's pretty much gonna button it up for us. Thanks for watching. Hey guys, welcome to Carcass. Well, we're down in engine power and we've got all of our systems buttoned up.
You guys want to stick around when we strap it to the dyno, because it's about to get rowdy.
Well, no surprise, we are working on the 72 road course Camaro one more time, but we do have some really big plans. By the end of the day, we are gonna have this thing down in engine power, strapped down to the chassis dyno, and we're gonna see what kind of numbers we can pull. Some of the stuff that we've gotten done most recently is we did mount up the coilovers up front here and some shocks in the rear. We have the engine and transmission sitting in its final resting place. Plus we worked on the brakes. We mounted up the stainless steel lines here, and we finished everything off by plumbing in the hard lines.
And we've also continued work in the driver compartment, finishing up the pedal box with the master cylinders, brake lines, and the reservoir, getting them all tucked away nice and neat whenever we're ready to beat on this thing on the track and the dyno. We also started working on our Aero package. We had the wing in-house, so we needed to design some pylons to mount it to the car. So we started with some cardboard, then transitioned into CAD, and then we sent our files off to Send Cut Send, where they laser cut them for us. Very painless process working with them, quick turnaround time, and of course the parts are super accurate. So I've got some base plates tacked in here. We're gonna go ahead and get the wing mocked up on in here and make sure everything's good. And then we can do the final welding and add some lateral bracing. All right, looks pretty good to me. Gonna have to fix this right here with some bracing.
Right.
But otherwise, yeah, I think we got it on the car pretty straight. We did take some measurements beforehand, so.
Cool.
We'll get this off and then get started on the fuel system.
Yeah, since we're back here, we might as well start that. I'll go grab everything I need, at least to get started back here.
Yeah, I'll get this out of the way.
Now to get started on the fuel system, we have to run 2 lines up to the engine. There is a feed side and a return side. And to get those 2 lines out of the trunk area, we're gonna have to install 2 of these bulkhead connectors up here, kind of on the little front panel of the trunk here. All right, now that we have the bulkhead fittings installed in the trunk, let's talk about how we're gonna plumb this thing up. We're gonna be using something called AN line, or other people refer to it as dash line with a number in front of it, so you can have like -4, -6, and -8. But this is what we are gonna be using. You have to use some special connections with this. The plus side to it is the connections screw on and they screw off to all of the fittings, kind of like our bulkhead fittings that we put in the Camaro. So you can access stuff or service stuff quite quick. Now, these are a little tricky to put together. It's not too complicated, but it's a little tricky, so we're gonna go ahead, put one of these together and just kind of show you guys how we do it. So like I said, this stuff is a little tricky to work with. Why I am putting tape around it is because I do have to make one cut on this. So the way that AN line is kind of put together, inside you have kind of this rubber casing or hose. The outside layer of that is some stainless steel mesh, and then even one more layer of this nylon or cloth style protective coating. That's what makes it really strong. But in order for me to get the big nut on for our connection, I have to have a nice clean cut, no frays like this. So that's why we put the tape on here. I'm going to cut halfway through the center of the tape. That'll keep it from fraying and give us a nice clean spot so we can connect that AN connection. Use the vise here to kind of hold this real loosely. And then we'll put a little bit of assembly lube on the fitting end. And we'll go ahead and thread it in. Then when we tighten this down, the trick here is you don't bottom this out. You want to leave about 1/8 of an inch gap between these 2 parts. All right, I went ahead and repeated the same process on the other side, and one thing to note here. When you build these lines, make sure when you're done you blow through them with compressed air or some type of a solvent. You don't want to get any of that debris thrown up into your filter, or worse yet, all the way up into your injectors. So this line fits. Just going to go ahead and repeat the same process for the return side. We'll attach this side to the bulkhead connector, and then we'll go underneath. So the plan of attack to get towards the front is we're going to come off of our bulkhead connectors here. We'll come up over the axle, and we're going to catch this frame rail down the driver's side of the car, cross over here on the floor, come up the trans tunnel area, over the trans cross member, and we'll come up here in between the trans and the new trans tunnel. And we'll go up to the firewall and catch the fuel pressure regulator. Okay, with our line made, we'll get started underneath the car here. We are gonna run this towards the front. We're gonna use these stainless steel little clamps that we got from Summit Racing and the riv nuts to kind of hold everything into place. So I've got a good idea where it's all gotta be routed. Now I just gotta install the riv nuts and the clamps. this in a couple stages. Make sure it's bottomed out all the way. There, we're good. 3 hours later, there it goes. Jeez. Okay, so I've got the line on the bulkhead connector. So we can get it somewhat up here with this first clamp and start traveling forward. All right, so up top here, I gotta make one more connection. That's up here to the fuel pressure regulator, and that is exactly what it sounds like. That regulates pressure to our injectors. So we have the line that comes in, it'll go through the regulator, over here to the driver's side fuel rail, loop around the back of the engine, then go to the passenger side. Do have another connection beyond that. Off the bottom here is a return side or a return line. That just has to go down, kind of follow the same path, and then go back to the fuel cell as well. So all I have to do up top here, finish making this feed side, finish up the rest of the lines, and that'll button up the fuel system.
Up next, we fabricate a fan shroud for our radiator to keep our engine cool. It's time to start working on the cooling system for our Camaro. Get this radiator mounted, and I'm taking a few measurements so we can start building out the fan shroud. We've got this nice 3-row all aluminum radiator from Mishimoto, and they also sent us 2 fans. So the idea here is I'm gonna make the shroud cover the entire core, and I'll make the top and bottom flanges a little bit longer so we can go ahead and put rivet nuts in these rails and then bolt the whole assembly on here. So I'm just gonna get these measurements into CAD, go over to the plasma and cut it out, and then we'll go ahead and break it and get this thing assembled. I've got the fan shroud all designed in CAD up to this point, and something that's really cool with these programs is that with sheet metal parts, you can do what's called a flat pattern, and what that does is it'll lay out exactly where the bend lines are supposed to go so that when you take your part to the brake, there's no guessing whatsoever and your part will come out perfect. Versus when I've done it by hand before, sometimes I'm not really sure how much material will be taken up in that bend, and then I might have to make things a few times just in case I screw it up. So I'm gonna go ahead and get this over to the plasma table, we'll get it cut out, and then head to the brake. I'll use a deburring tool to break all the sharp edges. And then I'll use a DA sander to give it a finished look. I have a fan shroud test fit on the radiator, so I went ahead and marked the holes out. I'll get a pilot hole drilled and then the rivet nut sized hole. Get the rivets in and we'll final install our shroud. All right, now I'm just gonna throw the fans on here, get this thing finally installed onto the radiator. And then it can go in the car.
This Mishimoto radiator and the fans are gonna work awesome in this car. And of course, it's great that this is a direct drop-in, so we're not gonna have to modify the core support at all. I'm gonna get Jeremy's help, get this up on here, we'll get some hoses, and that'll complete our cooling system. Up next, we install our carbon fiber drive shaft and our wheels and tires, and then we get our Camaro strapped to the dyno. Something that you guys have seen quite a bit, but we haven't talked about yet, are our wheels and tires. We got a set of 3-piece wheels from 3030 Autosport, and these guys really know how to make a high quality product. They're USA made with 6061 T6 aluminum forged centers that they cut in many different styles depending on what you like, and they have precision spun rim halves, and you can get a custom set made for any application depending on what offset and what look that you're going for. And for tires, we're going with a set of Hoosier A7 DOT approved slicks in a 315/3018. And these are just gonna provide a whole lot more grip than any high performance street tire that we could buy due to the softer rubber compound. If you guys have ever been to a track and have seen a car pulling off after a session, you may notice how many little pebbles and rubber marbles they get stuck in their tires just due to how sticky and gummy these tires get once they're hot. And that's something to consider too when you're building a car that you might take to the track. What kind of tires are you gonna need? With our Camaro, it's strictly a track vehicle and will never see any street driving, so going with a full slick makes a lot of sense. But if you have a car that's pulling double duty, or if you're someone that drives their vehicle to an event, then you're of course gonna need a street tire, something in the 200 to 300 tread wear range, and these tires are usually categorized as an ultra high performance summer tire. As far as price goes, tires of this size tend to be in a similar price range depending on the manufacturer, usually in the $400 to $600 per tire range. I'm really excited to get these on the car and see how they perform, but I have just a couple other things to do. One of the last pieces to go into our Camaro is the drive shaft, and we got this pretty trick piece from QA1 through Summit Racing, and this is one of QA1's custom carbon fiber drive shafts that was made specifically for our Camaro. And they have quite a few benefits over your normal aluminum or steel drive shaft in that they are a lot lighter, a lot stronger, and because they are so light, it will allow your car to accelerate much faster. They feature these CNC machined forged yokes that are installed using their proprietary bonding process and 1350 U-joints, making this drive shaft capable of 1500 plus horsepower, which I think will do just fine in our Camaro. One thing that was challenging though, getting this drive shaft done, was actually finding the correct yoke. If you guys remember, we have a mid-valley 4-speed, which is a NASCAR specific transmission, and just the same, the yoke itself is also specific to NASCAR. The one that was sent with our transmission was cracked, which we knew about, and it was just there solely for the purpose of sealing the tail shaft housing so it wouldn't leak during the shipping process. So we were actually able to reach out to the original manufacturer, and they had 2 left on the shelf, and they were able to send us one. And the reason why this is so unique is because inside the tail shaft housing there are 2 roller bearings that are spaced quite a ways apart, which is why this yoke has to be so long. And also because it rides on roller bearings, the yoke has to be made out of a hardened steel, versus in a normal transmission you usually have a bushing inside the tail shaft housing, which is a much softer material, and therefore your yoke can be made out of a normal steel. So I'm going to get this thing installed, and we'll be one step closer to getting our Camaro fired up. Once I get this installed, I'll throw the wheels and tires on it, and the next time you guys see this car, we'll be on the dyno.
Coming up, we've got the Camaro strapped down, Jimmy's in the hot seat, and we're gonna see if we can't peg the needle on the dyno. All right, guys, the time has come. Between Jimmy, myself, Pat, and Frankie, we have the Camaro down here, set up on the dyno, everything's strapped down. We have made a couple little runs here just to kind of square everything up, but Pat, really, we're not solely checking the engine as far as horsepower anymore. There's so much more involved in this now, right?
Absolutely. No, the engine ran great on the dyno. We know what it made, so this gives us a chance to make sure that everything in the drive line is right. The rear end, the transmission, everything is affected. Now, what we can figure out now is how much drive line loss we have, because we know exactly what the engine makes. So whatever it prints the tire, we know how efficient the chassis is.
And we've talked about this a little bit before as we were kind of figuring stuff out. We're not going to pull in fourth gear. That's the 1-to-1 ratio that you're always looking for. We're going to do it a little different.
Yeah, normally we would go for that 1-to-1, whatever gear that is. With this combo, with the rear gear that you guys have, and talking about the gearing, if we did it in 1-to-1, we'd be at like 180 mile-an-hour weir speed, which probably, you could do it, but probably not a good idea on the dyno, so we're gonna do it in third gear. It's a little bit safer. We'll get the same readings, the same numbers. We can still tune all the partial throttle stuff, so that's no problem. But yeah, third gear, probably a bit safer.
All right, well, Jimmy, you've had like one run at this, and you're gonna have to get used to the clutch again, so I guess fire this thing up and see what happens.
Let's hit it.
So this run, and I don't know if you can hear me, we're going from 4,000 to 7,500 RPM.
Good to go. Yep.
Nice. All right, Frankie, how are we
That's
looking?
a full pull right
See
there.
here, I got like 18 computers running, it feels
you
like.
got
but
too much stuff to run.
He's got like 8 computers over there.
Right.
That is right on the money, 562 horse. So there's a couple variables that go into that with driveline loss and stuff,
Right.
and you know, you guys will have an intake tube on it that gets some fresh air, but that's right, pretty much where it should be. And like you said, this is really about testing the car and the driveline and all that. So
Yeah, there's so many different aspects to this car that we've never dealt with, as far as all the oiling system, the fuel system is so far away. It's just, there's so much going on. Really, all we're trying to do here is to figure out, is A, B, C, and D working together? So,
yeah.
Oh no, there's a lot, and it has a little bit of pressure on there on the wheels, not like a conventional clutch vehicle, so nice job on that.
Yeah, you're
Yeah,
getting
good
it
job
figured out.
driving that clutch, yeah.
I will tell you that it's over like what seems like a split second, and my heart is pounding right now.
Yeah,
No,
something
it's
with this
awesome.
much power, it flies through the pool. So
Yeah.
Well,
That's intense.
do you want your heart to pound one more time? We can do another one, right?
Yeah.
I mean, why
Yeah.
wouldn't you? When we're here, we got to do a little bit of work on it anyway.
Heck
so
yeah.
I feel that number's going to go up.
yeah,
so.
we'll check the data log, and then we'll make another hit.
Perfect.
Yep.
Go for it.
Sweet.
Nice.
Very nice.
It gets better every time, I swear. Ooh, that's a good looking graph right there.
Yeah, 631.7,
631.
522 pound-feet.
I think that's
kidding me?
good.
That's, I mean, I'm not a mathematician, but that's really good, yeah. Squeaked a little bit out of her. She's a little safe, got her
That's just a
leaned out a
little
little
bit
bit.
of tunage just right there.
Yeah, that'll be
Yeah.
enough.
Oh, I mean, I don't know. It's, you know, it's a light car, so.
How'd that feel going through the pole?
Yeah, it's adrenaline every time. I'm like,
Yeah.
okay, we're right there, let's get off.
Got pretty loud when this pipe blew off, but that's okay.
Yeah.
It's going to be straight scary. Like, so we've got everything working now.
Yeah.
We just
Yeah.
have to figure out how to drive the car.
Yes.
Like, that is going to be a challenge in itself.
That sounds like a you problem.
Yeah, you'll
Yeah,
figure
your
it out.
problem's done already,
It'll be good. Don't worry about
No,
it.
that, very good, very good.
Yes,
Yeah,
good
thank you.
job.
Yeah, we
This
like
is
that.
awesome.
That was a very good job there, young
Yeah,
man.
good job driving,
Nothing fell
dude.
off.
Yeah, thank
Nothing's leaking. Everything looks great. Temperatures are great. Oil pressure's
pressure's
great.
good.
Everything sounds good. Rear
Yep.
end's not leaking. Everything is
Yep.
doing what it's supposed to.
Right.
Tune looks good. This thing's ready to rock and roll.
Yeah.
Yeah, so I think we've got our work cut out for us. We're gonna try to make the learning curve as shallow as possible, but it's still gonna be like almost vertical.
Yeah, and as far as work cut out for us, we got a lot more to do. So that's pretty much going to wrap it up for us today. We're going to get this thing unstrapped, head back down to our studio. What do you think, man?
Dude, this
That
is
was
mean.
Unbelievable.
Yeah, that's something I've never experienced.
Today on Carcass, our Camaro is torn apart so we can paint. Then we take the car back into the shop for reassembly and a custom wrap before taking it out and having a great day ripping it around on the track. What's up, everybody? Welcome to Carcass. All these parts and pieces you see laid out before you are exactly what it takes to build a race car. And you're probably asking yourself, where did all these parts come from? Well, they came off of our 1972 road course Camaro. You're probably also asking yourself, why in the world did we tear this car completely down when it was almost done?
The reason is we want to have this car finished and everything painted. So the easiest way to do that is to strip everything off the car, every single nut and bolt, and put it on this rotisserie so we can spin it around, make sure we don't miss a single spot. And then once it's done, we can put it back together and we'll have a nice finished product. But for now, we got to get this thing to the prep booth and start sanding.
This thing's super long.
Yeah.
The whole apparatus is super long. That should be good.
The process of getting this thing prepped is just a combination of sanding and scuffing the different surfaces to get them ready for paint. On the roll cage and the tubing structures up front, I just go over it with 180 grit sandpaper just to get through some of that mill scale. And that'll give the surface some scratches, give the paint something to bite to so it sticks and remains durable for a long time.
And what I'm doing to prep the floor is we're using a drill with like a wire wheel on it. Basically all we're trying to do here is use the wire wheel to clean up some of the areas and put sand scratches in the floor itself and then everything else around the inside of the car. That way when we go to paint, everything will stick. So then on the underside of the car, we're going to use the same process. We're going to be using a drill and a wire wheel. We're also going to be using the little grinder with the wire wheel on it. What we're basically doing here is trying to knock all of this old paint off or old undercoating off, or at least give us some really good scratches and all of that stuff, just so the paint has something to stick to. And then if there is any bare metal surfaces like the inside of the wheel tubs, we're going to hit that with some 180 grit just to kind of give that surface something to bite to when we go to paint it. Really the overall process here, this is a race car, so all we're trying to do is getting something underneath here and get the paint to stick and make it look good. All right, so now that we have everything prepped, the first place we're going to start painting is inside here, so we got to clean this all up. We'll wipe everything down, mix up some paint and start shooting.
Obviously there's a lot of tubing here I got to wipe down. I would estimate close to 100 feet, maybe if not a little more than that. So that's what you get when you spend probably 70 hours building a roll cage like this. A lot of prep work, whether you're building it or painting it. That's one thing people don't like doing is painting their own cages, but if you want it to look good, you got to put the time in.
So for the mask job that we're doing now is just kind of quick and dirty. What we're trying to do is just make sure we don't get a bunch of overspray all over the car because we don't want to go back and have to re-prep when the paint lays down. So we're just trying to mask off the big areas. A little bit of overspray gets outside of those areas, at least it lands on the paper and we don't have as much work to do.
The biggest challenge with painting roll cages is all the different angles that you have to hit to make sure that you get good coverage on all the tubes. I'm really trying to pay attention to getting enough paint on the tubes to give it that shiny wet look, but not hit the same spots so many times that it causes a run. Whatever spots I can't get to with the big gun, we'll come back later and hit them with a touch-up gun. We put the final touches on our paint, then head back to the shop to put our Camaro back together for the final time.
All right guys, welcome back. Now after we sprayed everything on the inside of the car with the white paint, we went ahead, unmasked it all, remasked the entire car and flipped it on its side. And now what Jimmy's doing is spraying the underside of the car with a chassis shield. All this stuff, or all the paint that we're spraying, came from Summit Racing. This will be great on some of the bare metal surfaces, but it'll also do really good coverage over the painted surfaces that were underneath. So he's kind of just getting at it, and we'll see how it turns out. So with this stuff, you're laying down 2 coats or 2 wet coats. You're going to give it about 30 minutes splash time or dry time in between each coat, and then you should be good to go. Now that we have the car masked off, we're gonna go ahead and spray the Summit Racing DTM, which is direct metal epoxy primer, mixed in a 1-to-1 ratio, and we're just gonna spray the rest of the car with this to finish it off.
Painting a car like this is great practice for me because I don't get to spend a whole lot of time behind the paint gun. And with a car like this, knowing that it's going to be wrapped later, it gives me a good opportunity to practice my spray patterns and make sure I'm laying down good coats.
So especially in this instance where the car is gonna have a wrap over the top of it, you don't have to be perfect with what you're doing. Jimmy's trying to do now is lay down a wet coat so it's basically smooth, and the wrap's just gonna go right over the top of this. So even if there's a little bit of debris or trash in the paint, we can nib this out and the wrap will go down and just look slick.
All right, we'll shoehorn it in here for the last time.
Just as long as that guy knows how to drive this thing.
Yeah.
Struggling right now.
All right, go down a little bit. Stop, go forward.
You mean backwards?
Yes. All right, stay right there.
Weasel this thing in here. Let's get this on here. Then we're gonna finish up the car. All right, now that we have the Camaro pretty much buttoned up, it's time to move on to some fluids. Now, since we pulled the car completely down to paint it, it's time to fill everything back up, starting with this giant oil tank back here. We're gonna be running Schaefer's High Performance Racing Oil. This is designed for high performance gasoline race engines, just like the Motown LS we have underneath the hood. Now, this is the same oil that we ran in the car on the chassis dyno, but since we had to pull the whole car down, it's time to fill it up with some fresh stuff. Schaefer's Supreme 7000 Synthetic Plus oil has a superior film strength for extra protection against wear. It has proven performance against thermal breakdown, which will help us in our Camaro since it's going to be seeing a lot of heat cycles. Plus, it's got friction modifiers, and that will help provide a strong barrier against scuffing and abrasion. Pat and Frankie have this figured out, so it's about 11 quarts in the tank here, plus the extra stuff. Our lines are a little longer, so we'll probably put about 11 or 12 in it. Should be good to go.
One last thing I want to talk about as we've been putting our car together is heat management. We're using quite a few products from DEI to help keep our car in good working order. The first one being spark plug boots. We have our coil packs on the inside of the car, so our spark plug wires are very long and they tend to be pretty floppy. So in the event that they are resting up against the header, the spark plug boots are going to protect them. The next thing is the exhaust. The headers run very close to the floor,
And so we want to keep as much heat out of the driver compartment as possible. And we also have our brake and clutch master cylinders right by our feet as well. So what we did is we put some of their floor and tunnel shield, stuck it up to the bottom of the floor, and this is going to reflect a lot of the heat away from our feet and away from the brake and clutch master cylinders. And the last thing is the fuel line runs right by the exhaust as well. So we have some of their heat shroud gold, and all of this stuff is gonna keep our car operating at a really high level.
Coming up, we cover our Camaro with a race-inspired wrap.
Hey everybody, welcome back to the shop. We have our Camaro reassembled, and now we're about to see it make its biggest transformation.
And that transformation comes in the form of a wrap. So we have Micah and Jimmy here from Graphic Effects, and they're gonna lay down a killer wrap on top of our Camaro. Now I'm a painter, so I know nothing about wrapping. Where do you guys get started? How do you do this?
Usually start with the design. We've got y'all's design finally laid out. I think we've got it nailed down pretty good. We've got some flat black, we've got some printed stuff. The only thing to do now is just to get sticking.
Awesome.
You want to start with the matte black?
Yep, let's do some
do
matte
it.
black and see where we go from there.
Awesome.
All right.
Sounds good.
When working with wraps, you do have to be careful, and it does take, you know, some thought behind it. You can't just close your eyes and throw it on there and magically it appears. There is a lot of technique to it. It's very situational, so, you know, it depends on the temperature. You know, it could be hot outside, but it's cloudy, and it acts one way. But if it's hot outside and the sun is out there too, then it's gonna act completely different. If you're inside and it's 40 degrees, you know, a lot of times the vinyl becomes brittle. It can tear. So it's very temperature sensitive. And then it just depends on what you're putting it on. Are you putting it on a clean car, a nice smooth paint? You do a block wall and it doesn't just stick to a block wall. You actually have to torch every inch of it. So there's techniques to do what you need to do, and certain situations require different techniques. The vinyl will tell you what it wants. You just gotta know how to read it, and you gotta know what to do when you see it. So it's kind of crazy. Obviously, if it's a race car, it's gonna see a lot of, you know, potential damage, even if it's just from debris, rocks, sand, anything from being rubber, from being coming off the racetrack. A lot of times you can clean it easily, and then if it does get messed up beyond repair, then you can replace that whole panel with either just a piece of material or a click of a button and print out a new fender. You don't necessarily have to repaint the whole car or reprint the whole car and rewrap the whole car.
Our Camaro has made a huge transformation, and we want to give a big thank you to Micah and Jimmy for doing this. This thing has completely exceeded our expectations and looks 100 times better than what we thought it could.
Oh yeah.
It does. This thing turned out great. It's really cool seeing the rendering and seeing the design, and when it comes to life, it's awesome.
Yep.
It turned out really good. Thank y'all for letting us do it. It was a great opportunity. And in the future, let us know. We can help you with anything else.
Absolutely. All right, a couple more things to do, and then we can hit the track.
Yeah, sounds good. Just amazing. This thing is just amazing.
Along with the safety features on our Camaro, we wanted to make sure that we stay safe as well. So we hooked up with Simpson and Holley Performance, and they gave us all of this personal safety gear when we're out on the track. Everything from shoes, socks, head sock, gloves, racing suit, Hans device, and a helmet. Just in the worst case scenario, it's better to be safe than sorry. This is Simpson's checker suit, which is SFI 5 rated, has satin twill Nomex knit fabric, and all of these products also have SFI ratings to give us that fire protection just in case something happens and we do have a car fire. We're also really excited about this Hans device, which for those of you that don't know is a head and neck restraint system. So in the case that we get into an impact, it prevents our head from doing that dangerous whiplash motion. We are really pumped to use this stuff when we're out ripping it on track in our Camaro, and we know that it's going to keep us safe. Stick around. We're at the track and having a blast, tearing up the pavement in our road course Camaro.
right, everybody, today is the day that we finally get to pay off our Camaro. This is one of those projects, as many of you may know, you work on it for a really long time and you kind of have these ups and downs and you're trying to figure out if it's all worth it, if you should keep sinking money into it, and if it's just worth your time to do it. And I can tell you, ripping this thing for the first time down the straightaway, it definitely makes it all worth it, because this thing is fast, it's mean, it hugs the turns, and it does exactly what we want it to do. We're out here at Polycarbonate Training Center in Fayetteville, Tennessee to put our car to the test. This track is 2.1 miles long and has about 120 feet of elevation change. It's a nice technical course that's really going to test our car and our skill set. So let's see what this thing can do. My first impressions of this car is that it's really fast, definitely faster than anything I've driven. I'm used to driving a pickup truck on the autocross course, so this is quite a different animal for me. This thing feels quite a bit more planted with the slicks on it. Of course, a pickup truck is really light in the rear end too, so this car feels really well balanced with the UMI suspension under it. And I think one of my favorite parts about this so far is shifting. Of course, we have the dog box transmission that came out of a NASCAR Cup car, and learning how to shift up and down, you know, we don't have to heel toe, we can just flip the throttle as we're going through neutral, and makes for a really quick shift and makes for a really fun driving experience. It's really impressive, the throttle response that this car has. This is the most horsepower I've ever had under my right foot. And it's almost kind of scary, especially coming down that hill, the way it pushes you back in the seat, because you gain speed faster than your brain can really react. So huge kudos to the engine power guys putting together this Motown LS, because this thing absolutely rips. All right, so we're coming on the back stretch here, really open it up and see what it can do.
Well, you looked really fast. How was it?
Let me tell you, the fastest car we've ever built, and it's gonna put the biggest smile on your face. So you get in and you drive now.
You don't have to tell me twice. I will gladly get in and drive the car. I'm a little scared, but I think I should be able to pull this off. You know, we've had this car in our shop for a long time. We've done a ton of work to it. And we really did start with a good, solid platform. We didn't have to replace any of the floors or really worry about major damage on the car, but it was a really good platform for us to build something just like what we're driving right now. You know, it took a long time for us to get to this point, but I couldn't ask for anything else. This car is an absolute animal. It's doing everything that we ask of it. We want to give a huge shout out to everybody over at EBC Brakes, because as everybody knows, a whole bunch of horsepower is no good if you can't stop it, especially in a car like this. So up to this point, this has all been kind of just a big dream for us. We wanted a car that could really perform, and to be honest with you, a car that could scare me, and this car is exactly that. With everything we've put into this car, it is a little bit more than I can handle, but it all works together really well. Watching Jimmy run this car around was amazing. For it to be in the hands of somebody that can really drive it, it just kind of shows you everything we've done, how it's all been put together, and just how much fun you can really have on a racetrack with a race-specific car. And really sitting in the seat right now, running this thing around the track, I am so happy with the way that it turned out. I just am grinning from ear to ear. It's so hard for me to focus on talking right now just because all I want to do is stab the throttle, hit those corners, and just have a good time out here.